Okay, good morning all. So today we want to move on to our next topic in networking, the biggest topic and the most important topic, that is network layer. Okay, so we have so far completed uh, the physical layer and the data link layer. So today we want to start the network layer. Okay. Right. We will not be able to finish it because this is the biggest topic. Once network layer is done, pretty much your syllabus is, it's something like your syllabus is pretty much done. Okay. Other topics are very small. Right. Again, I have enabled the note today, our note. Of course, the UCSC note is also available in the VLD. So I just uploaded our note as well. And also I have enables few links for the subnet calculators, which you can use to verify your calculations. Okay. And also you can use it to help understanding concept. This is one of the complicated topics. So a lot of students finds this topic as the most challenging topic. If you understand the concept, this is very easy. But if you don't understand and rather try to memorize things, you will find that this is the hardest topic, or it never works. Right? It never works. Because we need to do a lot of calculations. Right? A lot of calculations. But those calculations can be done only if you understand the concepts to the perfection. Okay. Right. So let's move on to the topic. Sorry. Right. Network layer concepts. Remember, this is the third layer. So we have the physical layer. On top of that, we have the logical link layer that handle the access, shared media. So the concepts like Ethernet, Wi-Fi, right, MAC address, switching, frames. So those are logical link layer. Of course, if you want, you can subdivide it into two sub-layers. Right. So those are very handy when it comes to local area networking. But especially when it comes to wide area networks and internet, network layer is the most important layer. Actually, in the OSI architecture, this is the most important layer. Sometimes we call this the internet layer. Okay. Right. So what are the concepts or what are the basic ideas behind network layer? So we will look at what are the major functionalities of network layer. And of course, we will look at what is IP protocol. That is a major protocol in network layer. What is IP address? So that is the address schema for the network layer, IP address. And then the most important thing is, and the most complicated thing to understand is what is subnetting. Okay, what is subnetting and how to do that. And also we will look at how the routing is happening in internet or any other network layer concepts. Okay, so that is our objective. Those are our objectives, right? So basically the major functionalities of the network layer is, or network layer are, facilitate the internetworking and routing, right? Internetworking and routing. So internetworking means connecting networks together, right? Connecting networks together. So that is called internetworking. So that is how the word internet came also. And how the maybe this particular machine need to communicate with this one, right? Maybe some machine in this one. So how does your data packet, so the data goes from your machine to the other machine? So that is called routing. That is more complicated than switching. Switching is relatively simple, actually very simple compared to routing, because switching is just take your data frame and send it to the correct machine. Just the machines are connected. So take your data frame and give it to the correct machine. So that is a very simple scenario compared to routing. So routing is your data packet starts somewhere here and ended up in the correct machine. Maybe data packet starts in machine in USA and ended up in machine in Colombo. So there are a lot of routers collaboratively routed towards the destination. Okay. So that is why network layer concepts are more challenging. Okay. So as I told you, there are a lot of challenges when it comes to the internet networking. Obviously, we need a common standard because these are different networks in maybe in different parts of the world. So therefore, we need a common standard. Then only a data packet starting from USA can ended up in a machine in Tokyo, right? Or machine in New Delhi. So then we need a global addressing schema. Global, right? Not just for your network. So global addressing schema. So we call it the internet IP address. Then of course we need the multicasting, broadcasting, because there are a lot of usages. For example, right now this YouTube, this particular uh, Zoom call or Zoom session is a multicasting. So data packet starting from my machine ended up in different machines, same data packets. So that is multicasting. So how do you support that in a very efficient manner? And also there are some, remember we are connecting different networks together. So these different networks may have different configurations, right, for the data packet size and so on. So how to handle those differences? Then the quality of services. Some applications need very high quality. High quality means you need, for example, if you are doing a file download. So if there are some issues in between, delays and so on, that is not a big issue because the person can wait a few more seconds until the download is complete. But if you take something like video streaming, computer game, online game, so we can't tolerate that kind of things. So if there are some delays, maybe one player will get some disadvantages. So if there are delays in data packet, the video streaming will be interrupted. You don't get that experience. Okay. So that is another concern for the network layer. And of course, the reliability, it is partly handled by the upper layer, the transport layer, but some aspects of reliability is handled by the network layer. But these are not the network layer tasks. Basically, these are the common challenges in internet networking and of course the security, right? So some of these aspects are handled by the network layer and some other layers also contribute in some, especially like security. For example, if you take HTTPS, so that is pretty much handled by the upper layers. But IPsec is something handled by a network layer. So you can see different layers contribute to security as well. Different layers contribute to reliability. Okay. So how do we do this internetworking? So that is interconnecting these networks, interconnecting different networks. Maybe this is one network, this is another network, another one, right? Another one, and so on. So two possible solutions are there. One solution is build devices that translate to convert packet from each kind of network, because these networks may be using different technologies. Right? One is wired, one is wireless, and so on. One is using one topology, another one is using a different topology. So then if we can build devices that can translate those differences, match those differences, translate one type of data packet and convert it to the type of data packet the other subnetwork can understand. So that is one solution. So then we heavily depends on devices to do the translation. So that is not a very practical solution because there are so many variations in technologies. So as an alternative solution or more viable or practical solution, what the iOS architecture proposed was build a common layer, and that common layer is called network layer. Okay. So maybe you are using different aspects in your below layers, especially logical link layer. One is using Wi-Fi, other one is using Ethernet. And of course, physical layer, one is using copper wire, other one is using fiber optics. But when it comes to the network layer, there's a common ground, common set of protocols, common addressing schema for these different networks to communicate with each other. Okay. So that is the idea behind a network layer. So then you don't need sophisticated devices that do a lot of translation when the data goes from one subnetwork to the other. Okay, so that is the idea behind network layer, having that common platform. Okay, right. So now we'll look at the network layer related concepts one by one. So basically, we will look at what is IP protocol, what is IP address, what is IP packet, what is router, what is routing, what is subnetting. So those are the concepts that we will be discussing in this particular session. So we will start with IP address. So remember, in logical link layer, we have MAC address. MAC address is a manufacturer specified address. You know that it has two parts. Left part is the manufacturer number. The right part is the serial number. So the MAC address is supposed to be unique. But other than that, it has no other meaning. It's just a unique number. It has no other meaning. And the other thing is MAC address is hard address. It is hard. Sometimes we call it hardware address or physical address. But in reality, it is more firmware address. At firmware level, we set it. Remember, NIC network interface card has firmware. But anyway, it is not soft address. It's not very flexible. So there is one issue with MAC address. We can't change it easily. The second one is this MAC address has no meaning about your network or the location of your network. It is just the manufacturer ID and serial number. So that is why in layer 3, we have much more flexible addressing schema. One thing is it is a soft address. We can set it by ourselves, or system administrator can set it very easily. It's a soft address, not a physical or hard address. The second one is these IP addresses are standardized. So IP addresses are managed by ICANN, Internet Corporation for Assigned Names and Numbers, another body related to Internet. Actually, one of the main body related to Internet, administrating Internet. So they manage IP addresses. So they have assigned different IP addresses into different classes, and they have assigned different IP addresses to different countries, and so on, in a very systematic manner. And of course, we can get one of those IP address from our internet service provider. So therefore, we have the two advantages. One is it is soft address where we can change it. For example, when my laptop is connected to, say, my home and network, I get one IP address. When I go to office and connect to the office network, now my laptop has a different IP address, which is meaningful for my office network. But MAC address is not like that. Okay. And of course, not only we can change it, it has a meaning. Okay. Right. So then there are two versions of IP addresses, what is known as IP version 4, IP version 6. So IP version 4 is the older one. Version 6 is the newer one. Actually, we are now in a transition. We are in a transition from V4 to V6. So therefore, effectively, what we get is we get both V4 address and V6 address. Because there are some old devices, old routers and so on, still they don't understand V6 addresses. So therefore, if the device understand V6 address, it will use the V6 address. If it does not understand V6 address, it will be using the V4 address. So therefore, our devices have two addresses, V4 and V6. And not only that, our data packets also having both V4 and V6 address. Okay. But in the future, maybe after some years, so gradually V4 will be discontinued. But still we are in the transition. Okay. So during our discussion in subnetting and so on, we will be concentrating on V4 address because that is what is in your syllabus and that is what is mainly used, still we mainly use. Okay. But we will touch a little bit about version 6 address as well later on. Okay. So if you have any questions, you need to ask then and there. Okay. So I told you this is the hardest topic. This is the hardest topic. This is not the easiest topic. This is the hardest topic. Okay. Right. So this is the format of IPv4 address. So it has 4 components and each component is a number between 0 to 255. 0 to 255. Why is it 0 to 255? At binary level, it is a 8-bit number. If it is 8-bit number, the smallest number is 8 zeros. That is 0. The biggest number we can go 8 ones, that is 255. So therefore, each number is between 0 to 255. If it is outside this range, that is definitely not a valid IP address. Okay. And how do you assign IP address to your machine? Remember, you can assign IP addresses to any node that is connected to a network like laptop, smartphone, desktop. Not only that, you can assign it to utility devices like printers, scanners, if you want to directly connect to the network. And of course, IP address will be assigned to something like a router, those network utilities. Okay. So how do you assign? I told you IP addresses are very flexible, soft concept. So you can assign an IP address to a particular machine or device either statically or dynamically. Okay. Statically. Right. So I use the word statically, dynamically. Then later I will talk about dynamic IP address and static IP address, two different concepts. Statically means you go and set up it. Right? You go and set up it. And it is sort of a until you reset up it or reconfigure it, that IP address is used. So that is called statically assigned IP address. So dynamically assigned means another server will give you the IP address. So we don't statically assign it. So when you connect to the internet or your network, you assign the IP address by your network router or any other networking server. Right. So there we use what is known as DHCP protocol. right? DHCP protocol, dynamic host configuration protocol, and DHCP servers are there in routers. So your DHCP server will send your laptop an IP address and assign to you rather than you assign it. Okay. So there is a difference between statically assigning IP address and dynamically assigning IP address. Almost right 100% or 99.9% of the time, we will be using dynamically assigned IP addresses rather than we set. So if IP address is assigned statically, when you connect to an network, before accessing the network, someone or you yourself need to set the IP address. So if you don't do that, or no one comes and set the IP address, and still you can use the network, so definitely it is dynamically assigned IP address. Your machine get an IP address from the DHCP server. Okay. So in my laptop also, it is dynamically assigned IP address. I don't set up the IP address. I haven't set up the IP address in my laptop. These days, almost all the time, statically dynamically assigned. But for example, about 10 years ago, when I was in the industry, when I moved from one project to another project, say different location, so either I have to set my IP address or the system administrator will come and set up IP address in my machine. So at that time, we heavily use statically assigning IP addresses. But that is no longer the case most of the time. But still, if you are working in a company environment, maybe still they are using that. Especially in that kind of environments where very high security is needed, still we use the statically assigned approach. But especially in casual environments, we heavily rely on dynamically assigned IP addresses. So it's very important to understand these things in the very first step. Because if you don't understand, or even worse, if you misunderstand, so then you are in real mess. Okay, so therefore, in the very first instance, understand it in the correct way. Because once you misunderstand, so that carries to the next concepts. Okay, right. So how do you statically assign IP address to a computer? For example, say this is my laptop environment. Okay, network. Turn off. Why is that? So let's see why is that. And yeah. So you can go to the open. In with the latest updates, they have changed some settings. Let me double check. They have changed the settings. Okay. So let's go to the settings. But you can see IP assignment automatic. Okay. So this says IP assignment for my device is automatic or using DHCP. So that means IP address is assigned dynamically from the connected DHCP server. If you want, you can edit it to something like manual. So then, of course, you can enable your IPv4, IPv6, and then you can set this is my IP address, this is my subnet mask, this is my gateway, this is my preferred DNS, and so on. So then the IP address you assign here is your IP address, is your machine's IP address. Remember, IP addresses are soft concepts. So you can assign whatever the IP address you want. Of course, if it doesn't make sense to your network, that is a different story. Just because you have assigned IP address, it doesn't mean that it always work. Your network must identify it as a valid IP address, but you have that flexibility to set it manually. Okay. But in my case, you can see that I have not used it. I have just by default, actually, when you install operating system, it is IP assignment is automatic. So that is dynamically assigned the IP address. So basically my router has a DHCP server. That DHCP server, when I connect to the Wi-Fi network, DHCP servers assign me an IP address dynamically. Okay. Not I have set up an IP address statically. Okay. Right. Actually, this is the old interface. I need to change this because now you can see that they have changed the interface. So they have taken that to the settings. Okay, so I will change this. Actually, today only I experienced this. About 2-3 months ago also, this interface was there. I don't know whether still this interface is there somewhere else, but it looks like with some Windows updates, they have taken this to the settings, right? The formal settings. Okay. Anyway, I will double check and change this slide. Okay. Right. So the second option is I told you we can get the IP address dynamically from the DHCP server. In that case, the IP addresses are configured in the DHCP server, not in your machine. Your machine just get the IP address. Okay. So then, of course, for example, in my home environment, my router, you must know how to access your router. Basically, when you have the internet or network, ISP provider gives you those details to you to change your Wi-Fi password and so on. So you must know your how to connect to your router. So in my case, it is 192.168.1.1. And this is my username and password. Okay. And I log in. So you should be able to log into your network, whether Wi-Fi or ADSL. Of course, this interface might be different depending on your router, right? This is the interface for my router. It will be slightly different. Okay. Of course, I have Huawei router provided by SLT. So then I'll go for the detailed setup. And here so these are the basic things. You have the status, whether you can see that this memory usages, CPU usages, system time, whether it's up and running and so on. Okay. So then you have the WAN related things. Of course, I am not connected to wide area network, the LAN related things, IPv6 related concepts, WLAN security, right? Firewall, forwarding rules, some net routing rules, and so on. Okay. Right. So we are more interested in DHCP information. DHCP information. Now you can see that. So this is basically my laptop, Dell laptop, and it has been assigned 192.168.110. So that is the DHCP server has assigned 192.168.110. So if I take command line, so I'm doing this slowly because this is something I told you. A lot of students pass network subjects sometimes second to third attempts. First attempt they just miss it, right? Because they are not serious. So you can just type ipconfig. So my IPv4 address assigned to me by the DHCP server is 192.168.110. You can see, because The DHCP server assign it to me, it knows, obviously. And of course, this is the MAC address that it has obtained from. So it has assigned me the IP address and it has obtained my MAC address of my Wi-Fi router. Of course, MAC address, if you want to see, here you don't see the MAC address. You need to type IP config all. Okay. So this is my Wi-Fi adapter. So it has obtained my physical address, my physical address. And it has assigned me the IP address. Okay, IP address. So that is dynamically assigning IP address. Okay, dynamically assigning IP address. And of course, we can configure what is the IP address range that the DHCP server assigned, and those things, of course, we can set up. Right? We can set up using this interface. Okay, using this interface. Right, so that is what is mean by dynamically assigning IP address versus statically assigning IP address. Okay. So then, of course, there's another concept called static IP address and dynamic IP address. Okay, static IP address and dynamic IP address. I will come back to public and private IP addresses later. Okay. So static IP address means your IP address is always the same. Right? Your IP address is always same. It doesn't change. Dynamic IP address means your IP address can be changed. It doesn't mean that, so right now it is one address, in 10 seconds another address. No. So when you connect to the network, the network will assign you IP address. But when you disconnect and again connect, there's a possibility that you get a different IP address. If that possibility is there, then it is dynamic IP address. Of course, this dynamic IP address is possible if your IP address is dynamically configured. Right. If it is statically configured, of course, always you have a static IP address because no one is changing it. Okay. So dynamic IP address means you may get different IP address at different connections. So you connect to the same network today, one IP address, tomorrow you might get another address, or you get the same address. So static IP address means either you have statically assigned that IP address, of course, then it is your static IP address, or when you connect to the network, the network has configured such that you always get that IP address. So that means you always get that IP address. So then also it is static IP address. So you can get static IP address in two ways. One way, you have set up it statically in your machine. So then that is your static IP address. Or in the router or the DHCP server, they have configured for your MAC address, they always assign the same IP address. So then again, you get a static IP address because every time you connect, you are assigned the same IP address. Okay. So here we can set up a static IP address. I'm just looking for that. Where is that? I should be able to set the static IP address for a device here somewhere. I can't remember exactly where. So definitely that feature is there. Just give me 1 minute. Right. Here you can set up. You can see DHCP basic IP configuration. I can go for new and say for this MAC address, you have to type the MAC address and this is the IP address. So then what happens is every time a device with this MAC address connect to the DHCP server or the network, it will be assigned this particular IP address, which we have predefined. Of course, this IP address must be within the valid range in your server. So then it is, though it is not statically assigned in the machine, we always, or the DHCP server always give that same IP address. So then also it is static IP address. Okay. So that is how you can get static IP address two ways. Either it is statically assigned in your machine, or the DHCP server has been configured for your MAC address to always give the same IP address. Something like using this interface. And here you can see some more DHCP server configurations. So this is the start IP address. This is the end IP address in this particular network. So therefore, my devices, if for example, my laptop is connected, my laptop must have an IP address between this one to this one. Of course, my IP address is 192.168.110. Like 192.168.110, of course. So you can see that 110 is between 1 and 1.2 and 1.254. So it has given me an IP address between in this range. So if another machine is connected to my Wi-Fi, it will be getting another number, maybe 111. And of course, since those are dynamically defined, so they different times. For example, if I disconnect my laptop and again connect, I might get something like 192.168.125. Anything within this range. Okay, anything within this range. And of course, the IP address is not a permanent thing. It is lease. For example, in this router, it is configured to lease for 3 days. So that means when an IP address is assigned to a machine, we are assigning it for 3 days. So after 3 days, if you are still connected, that lease might be extended, or if the lease is expired, sometimes that device will be assigned a different IP address because it's dynamic. So that is how it works. Okay. So there are a lot of things for you to think when it comes to networking. Okay. So later you will understand what is subnet mask. Okay. And this is the IP address of the router itself. So router itself has assigned an IP address because it must be identifiable by others. So the router itself has assigned the first IP address 192.168.1.1. So then 1.2.1.254 is free for the other devices. Okay. So if you want, you can enable another DHCP server as well. So in case this DHCP server is down or having issues, then machines will be connecting to the other DHCP server. Okay. Right. So now you must have a very good understanding about what is meant by statically assigning IP address, dynamically assigning IP address. When statically assigning IP address, always you have a static IP address. When dynamically assigning IP address, maybe you are getting a dynamic IP address, or maybe still you are getting a static IP address because you are always getting the same IP address configured in the DHCP server. Okay. So static IP address always having this assigned IP address. Dynamic IP address, your DHCP server will give you sort of a random IP or the next available IP address at that time. So when do we need static IP addresses? So most of the time, dynamic IP address is more than enough. More than enough. So that is why by default, you get the dynamic IP addresses. But especially if your machine is something like a web server and it is mapped to a domain name, say your machine is a web server and it hosts a website in the internet, say abc.com. So then you know that abc.com domain name is map to a IP address. So that IP address must be your machine's IP address. So then only data packets come to you when someone try to access abc.com. Now, in that kind of a situation, you have already published your IP address and domain name to the DNS servers all over the world. Now, if your machine is getting different IP address at different time, so all your DNS published DNS details are invalid. So therefore, if your machine is a server mapped to a DNS or domain name, then you must have static IP address. You must have a static IP address because you have published the IP address to the DNS servers. So that is the only place, or not the only place, that is where having static IP is a must. In other cases, dynamic IP is not an issue. Okay. And there are some advantages of having dynamic IP address also, because your IP address is keep changing, right? Time to time, not all the time, maybe session to session. Your IP address is not tracked. If someone try to hack your machine, somehow they find the IP address today, but tomorrow you are connecting to internet using different IP address. Okay, so that is an additional advantage. You get some sort of a anonymity, pseudo anonymity, privacy when you use dynamic IP addresses. The other thing is we are running out of IP addresses. That is why we are moving to the IPv6. So if something like telephone numbers, if you dedicatedly assign an IP address to the user, now actually there are more internet users than available number of IP addresses. So then if now what happens is then we don't have enough IP addresses. If each and every user is permanently assigned an IP address, but so that is why ISP providers, they don't give us permanent IP addresses like permanent telephone number, because they manage the smaller number of IP addresses with large number of users by dynamically allocating the same IP address to different users at different time. So therefore, when you are getting a dynamic IP address, that internet connectivity, you don't have to pay extra money. But for some reason, like you are hosting a website or something, if you need a static IP address, you need to pay extra to the ISP provider. Then only they assign you static IP address all the time. Because reserving an IP address for you is a costly thing. Because we are running out of IP addresses. Okay. So have you got any questions, or are you clear about the static IP versus dynamic IP? Right. So next classification is, so we are just setting the background, okay, for subnetting and other concepts. So the next, the very important and sometimes very confusing classification is private IP address versus public IP address. So this is completely different concept. This has nothing to do with static versus dynamic. So some IP addresses in the valid IP address range, right? 0, 0, 0, 0 to 255, 255, 255, 255. From this, so how many IP addresses we can make? 255 into 255 into 255 into 255. So let's take a calculator and see how many IP addresses are possible in IPv4. That is how many total IP addresses possible. There is no possibility of creating more than these IP addresses into 255 into 255 into 255. So this number of IP addresses. Okay. So this is basically 8 million. Okay. So that means 4,228 million IP addresses. So unfortunately, we are running out of IP addresses. So this number of IP addresses are not enough for the internet, because every country, almost everyone in the is having an IP address if he or she is connected to internet. Okay. Now, out of these IP addresses, these 4,228 million IP addresses, some of the IP address ranges are reserved as private IP addresses. Other IP addresses are public IP addresses. So therefore, out of these billions of IP addresses, some ranges are private, some ranges are considered as public. Okay. And if it is a public IP address, it is routable in the internet. So your routers can understand your IP address and route it towards the correct destination. So basically, these public IP addresses have a geographical meaning. By looking at the IP address, a router can say, is it from Sri Lanka? Is it a machine in Sri Lanka, Korea, or Brazil, or whatever? And that public IP address must be unique. No two machines can have the same public IP address. Public IP address is a unique IP address. If my public IP address is that, so no other machine in the internet must have that same public IP address. Okay. And again, there are small tricky scenarios because these public IP addresses can be cleverly manipulated by ISP providers. I'm not going into those tricky scenarios right now, but for the time being, just assume public IP address must be theoretically unique for the particular machine or device. Okay. And therefore, these IP addresses are, of course, all the IP addresses are managed by ICANN. So ICANN has assigned different public IP address ranges to different countries. So then within that country, it is assigned by their authority. In Sri Lanka, I think it is called, how do you call it? Telecommunication Regulation Authority, or TRC. So they have assigned part of the IP addresses to SLT and so on. Now, you know that there was a big legal battle also because now that I think that Airtel has been acquired by Dialog. So then as part of that acquisition, not only the hardware, their infrastructure. So Dialog get additional IP address ranges and so on as well. Like some bandwidth and so on as well. So therefore, there are some concerns with people saying that all of a sudden Dialog gets some undue advantage through this that acquisition. Actually, SLT went for courts challenging that. So then there was a political involvement, and so the actually chairman had to go home. SLT chairman had to go home. A new chairman was appointed, and the new chairman just withdrew the court case, allowing the transition of or acquisition of Airtel by Dialog. So you must be aware of these things as well, right? So there's a technical aspects behind that, political aspects as well, political law, the business aspect as well. Okay, right. So those are public IP addresses. Then private IP address is an IP address assigned to a machine by your local DHCP server. For example, remember my private IP address is, actually my IP address is, I told you, 192.168.110. So this is basically a private IP address assigned to my laptop by my router or the DHCP server in my router. So this is a private IP address. Actually, this is not my real IP address. I expose or I represent to the internet. So I will be represented. I am in. So my presentation to the internet is through a public IP address. This is my presentation to my network, my Wi-Fi network. My Wi-Fi network identify me as locally, as 192.168.110. But my machine is exposed to the internet through the public IP address assigned to my machine. So what is the public IP address assigned to my machine? Remember, this is a 192 number. For example, you can go to internet and say, what is my IP address? Just do a search and go to one of these sites. Right. So it's still checking the video. You can see it is 112.134.242.170, but that is my public IP address or public IP address assigned to my machine, or very specifically to my network by SLT. You can see ISP is SLT and some information and how it is connected to the internet, right? I think from somewhere, Mirisa or somewhere, there's connection to the C line. Okay. And this is my IPv for public IP address, whereas this is my IPv for private IP address. Those are two different addresses. So private IP address is used internally for inside the local area network. Public IP address is used by routers to communicate with my machine, sending data packets to my machine. Okay. There is a difference between public IP address and private IP address. Remember, public IP address must be unique, but private IP address can be duplicated. For example, maybe the same private IP address assigned to my computer by my router, maybe the same address is assigned to your computer by your router. That is perfectly fine because those are private, right? Those are private. So therefore, those private IP addresses ranges are published. So any router can use those private IP address ranges within their network. It has no conflict. Okay. But public IP address must be unique. Okay. Any question? Right. So we'll take a small break. And after the break, we'll move on to the classes. So that is another concept. Class A, Class B, and so on. Okay. Right. So we'll be starting at 9:50. Okay, so let's continue. Now remember we have IP addresses from 0000 to 255, 255, 255, 255. And those IP addresses have been classified into different classes. And we call them the Class A, Class B, Class C, Class D, and so on. Okay. And different classes, actually this concept of class is getting less and less useful these days. About 10-15 years ago, the concept of class was a very important concept. But now we are moving from class full IP addresses to classless or class full routing into classless routing. So therefore, this concept is getting less popular. But especially for the exam perspectives, the examiners are still really interested in this concept of classes. But this concept of classes is only useful, or we need to understand that when we are doing subnetting. So when you get into subnetting, we will revisit this concept of whether it's a Class A, Class B, Class C address, and what is the limitation of Class A address, what are the limitation of Class B addresses, and so on. Okay. Right. So now we move on to our most important concept, subnetting. Okay. Subnetting. So subnetting is basically creating subnetworks. So we can create a network and then we can break it into subnetwork. Then that subnetwork, maybe we can break it into further subnetworks. So it creates sort of a hierarchical network. hierarchical networks, and that network has subnetworks, and that subnetwork can have further subnetworks, and so on. So how do you do that? When we do subnetting, we need to use the concept of IP address in a very systematic way. So it's all about manipulating your IP addresses in a very clever manner. Okay. So that routers can route the data packet to the ultimately to the correct small subnet and the machine. So it goes through different subnet and ultimately ended up in the correct subnetwork. So it is possible because all over the world, especially in internet, so we are doing this subnetting properly. So system administrators do it properly. Of course, if you don't do it properly, you will not get the your subnetwork is not going to work properly. Okay. Right. So what is the idea behind subnetting? So I told you that IP address has 4 components. Something like 192.105.23.84. So this is my first component, second component, third component, fourth component. So that division is basically because we take 1 byte for each component. Right? So therefore, each one using 1 byte, we can give decimal number between 0 to 255. So therefore, we just write it because it's convenient for us. Easy to remember. Saying that 192.151.05.23.84 and so on. Okay, but that is just to remember the IP address for humans. Other than that, this has very little usage, breaking it into these four portions like that. You can physically see that there are 4 portions, but the more important subdivision is not something like this. Because for the computer, an IP address is here's in 8 bits. So this is another 8 bits. This is another 8 bit. And this is another 8 bit. Right. So therefore, it's basically IP address for a router or any other device. IP address is 8 into 4, 32 bits. It's just 32 ones and zeros. Right. It doesn't, for example, this 8-bit separation is not a very important for concept for the machines. Okay. So rather, there's a separation which is more important in subnetting. That is, you can subdivide your any IP address into 2 parts, like somewhere here. Right. So it can be somewhere here, or it can be somewhere here, or it can be anywhere. You can break it into 2 parts. Okay. You can break it into 2 parts. Maybe 7 bits here, 29 bits here, or maybe 10 bits here, 22 bits here, altogether 32. Okay. So it can be anything, maybe 16 and 16. So then we call the left side from that border. Remember, we do it at the bit level, not base 10 level. For computer, IP address is 32 bits, 32 ones and zeros. So then the left side is called the network ID. Right hand side part of that set of bits are called host ID. Host ID. Okay. It is something like, say, you have a house. Say it has 3 stories. Maybe you are given something like 32.1, 32.2, 32.3 as the house numbers. So basically 32 is your building. It's like your network ID. Then 1, 2, 3 are your individual houses inside that building. So anyone can identify the building using 32, but each internally the house is identified by 1, 2, 3. So therefore this is 32/1, 32/2, and so on. So therefore this is your network ID. So therefore it's something like this is your building ID, something like, okay, something like this is your building ID, this is your inside the building, the home ID. Okay, network ID, host ID. So that is how they start doing it. But then we needed to break a subnetwork into further subnetwork. So that subnetwork into further subnetwork. So that is where we require break it into 3 parts. Still the network ID is there, but we can borrow a few bits from the host ID and use it as a subnetwork ID. Then this is your host ID. Okay. Now we have the network ID part, subnet ID part, host ID part. Okay. And if you need, you can borrow further bits from, remember we always borrow from the host ID side. Say these IDs are for the host. It's a one subnetwork. Now, if you want to break it into 2 subnetwork, you can borrow a few bits from the host ID and extend the subnetwork ID. So that means we may have divided that subnetwork into 2 further subnetworks. So likewise, you can keep doing this. You can keep doing this. So that is the idea behind subnetting. That is the idea behind subnetting. Okay. So it happens at binary level, not at base 10 level. So therefore, though we say that they're like 192.246 and blah blah blah, it has very little meaning when it comes to subnetting. So the better meaning is at 110 level. And those 8 boundaries has less significance. Rather, these are the 2 important boundaries. The boundary that separate network ID and subnet ID, the boundary that separates subnetwork ID and the host ID. Okay. Right. So when it comes to subnetting, there are 2 approaches. Class full subnetting, which is the old approach, but still examiners are interested in class full subnetting. And then the classless subnetting, the newer approach. So you must know both. And once you understand the class full subnetting, basically you just omit one concept and all of a sudden you know the classless addressing. So therefore, sorry, classless subnetting. So therefore, first we will learn the class full subnetting. So then all of a sudden you will understand what is classless subnetting also. Right. In class full subnetting, that is subnetting using the concept of classes, IP classes. So there are predefined classes which are defined by ICANN. So they categorize IP addresses into different classes. Okay. Class A addresses, class B addresses, and so on. Okay. And these are the classes defined by ICANN. Class A IP addresses, Class B, Class C, Class D, and Class C. So out of those, class A, B, and C are used for subnetting. That is day-to-day our networking purposes. Class D range is reserved for multicasting. And class C is reserved for experimental or research purposes only. Okay. So we are not interested in, of course, this is reserved for the researching purposes for these guys. We are not interested in multicasting right now. So we are interested in subnetting. So therefore, we will be using class A, class B, or class C addresses in subnetting. But remember, we have class D and class C address ranges as well. So how do you know whether an IP address is a class A or B or C or D or E? It's very easy. If the IP address range is, if your IP address is in this range, it is a class A address. 0000 to 127.255.255.255. So the next address is 128.000, right? So if it is 128.000 to 191.255.255.255 range, it's a class B IP address. So the next one is 192.000 to 223.255.255.255. It's a class 3 address. And similarly, next one is 224.000 to 239. 255.255.255 class D, and then 240.000 to 255.255.255 class C. So don't worry about class D and class C, but you need to remember if it is 0 to 127 class A, 128 to 191 class B, 192 to 223 class C, then of course you have the D and E, etc. For example, my local IP address is 192 number, right? 192.168.110. So it's a 192 IP address. So that means it's a class C address. So my local IP address is a class C address. And remember, I check my public IP address using internet site 1112 number. 1112 number. So 1112 number is, in my case, class A address because it's 0 to 127, right? 1112. 1112 is between 0 and 127. So my public IP address is a class A. My private IP address is class C. But it doesn't matter. Don't worry whether your one is class A, my one is class A, your one is class B. It doesn't matter much these days. Okay, these days it doesn't matter much. But just you can check by looking at the IP address and see whether which range your IP address belongs to. So then you can say whether it's a class A1 or class B, class C. So if you are really curious about how these ranges are determined, කොහොමද මේ 124 මේ magic number ද කියලා. So it's basically if the, now remember, so this is my last octal or the leftmost octal. Remember we have 4 portions. So if you take this last or the leftmost 8 bit, because it's binary ultimately, if that value is 0, the first bit, basically the first bit, the leftmost bit is 0 means it's class A address. So the IP address range that has the first bit 0 is 0.0.0.0, that is the smallest. To the biggest is 0, all these are ones, then all the rest of the stuff are 1, rest of the stuff are 1. So that is basically 0 and 1111, 1111, then again 8 ones, 8 ones, 8 ones. So that is 127.255.255.255. So basically, how does your router check whether a data, because the data packet has the destination IP address in binary. So it just check whether the first bit is 0. So destination IP address is in binary number in your data packet. So it just check what is the leftmost bit's value. If it is 0, it knows that it's class A. Okay, it knows that it is class A. That's it. And if the first bit is 1, then check the second bit. If the second bit is 0, it know that it is class B. First bit is 1, second bit is 0 means class B. So therefore range is 1 0 all zeros to 1 0 all ones. So 1 0 all zeros is 128191. Okay. Blah blah blah. Sorry, 128 blah blah blah. 1 0 all ones means 191. So this is 128. එකසිවිසියට අනිත් ඔක්කොම බින්දු. මෙතන තියෙන 128යි මෙතන බින්දු අනිත් ටිකයි එකතු කරලා බලන්න. say 1 2 4 8 16 32 and 128 වාට 191 කියලා. So that is the biggest possible. Of course the rest of the stuff will be all ones 2 5 5 2. So that is how this range came. That is how the second range became, the class B range became 128 to 19. So if the first bit is 1, the second bit is 1, then it will check the third bit. If third bit is 0, it knows that it is class C. So therefore range is 110 all zeros to 110 all ones. That is 192 to 223. And it goes like that. But anyway, you don't have to remember it. කොහොමද වෙන්නේ කියලා තේරුම් ගන්න ඕනේ නේද? That is just for your information. නැත්නම් ඔයගොල්ලෝ හිතනවා මේ කොහෙන්ද මේ 127 නේද 191 224 ආවේ කියලා නේද? If you are a critical thinker, because everything must have a logic නේ. මේවා engineers ලා කරන දේවල් logic එකක් තියෙනවා. මේ භූත විද්‍යාඥයෝ පූජකයෝ කරන දේවල් නෙමෙයි. ඒකට ඒවයි logic නැහැ. හැම දෙයක් පිටිපස්සෙම හේතුවක් තියෙනවා. So that is how this range comes. But when it comes to your practical usages, so just you have to remember that 0 to 127 numbers are class A, 128 to 191 numbers are class B, 192 to 223 numbers are, that is the first octal number only you have to look at. They are class C numbers. Okay. And those are the numbers we use in subnetting. මේ range වල තියෙනවා අපි subnetting වල use කරන්නේ නැහැ අතට. Right. So then, still I didn't explain you why did they break those IP addresses into classes? Why did they do that? One IP address range considered as class A, another IP address range considered as class B, another address range considered as class C, and so on. So the original thought was, right? Original thought was they wanted to break these IP addresses into 3 type of pools. So they thought, now remember there's a separation, right? This is net ID, this is the host IDs. This range is for the host ID. This part is for the net ID or the subnet network ID, host ID. So if this line is somewhere here, we have less bits for the host, more bits for the network IDs. මම කියන එක තේරෙන්නේ නැත්නම් ඒ වෙලේ අහන්න ඕන හැබැයි යා. So if this is somewhere here, that means we separate like this. So that means we have lesser number of bits to assign to bit patterns assign කරනවා machine වලට පස්සේ යා. So for example, if you have only 2 bits here, say 30 bit here, 2 bits here, then we have just 4 possibilities here for host numbers, host IDs. That is 0 0 0 1 1 0 1 1. But here you have 2 to the power 30 possibilities. This is 2 to the power 2 possibilities for host. But we can create 2 to the power 30 number of networks with 4 host machines. Host machine 4ක් තියෙන network 230ක් හදන්න පුළුවන්. 230ක් කියන්නේ 1024 වැඩි කිරීම 1024 වැඩි කිරීම 1024 මිලියන ගාණක් හදන්න පුළුවන්. On the other hand, if you take something like somewhere here, say 4 bit, 28 bit, අපි එහෙම හිතමු. So then we have 2 to the power 28 different host IDs for a particular subnet or particular network. It's a huge, but we can create only 2 to the power 4 such network. ඒ වගේ network හදන්න පුළුවන් අපිට 16යි. ඒ network එකට දෙන්න පුළුවන් මිලියන ගාණක් machine. So the original idea was, right? So use class A when you need large number of host machines in the network. That means big networks. But you can create only 256 of that kind of class A networks. Because that separation will be at the end of the first octet. 8-bit, 24-bit. So here you can create 2 to the power 8 number of networks like that. ඒ වගේ network 256යි ලෝකෙටම හදන්න පුළුවන්. But if you take such a network, each network can have this number of machines or host IDs or host IP addresses. That is 16 million host addresses. එක network එකක මිලියන 16ක් machine වලට IP address තියෙනවා. එහෙනම් network 256 හදන්න පුළුවන් class A වලින්. If it is class B, the separation is 16 and 16. That means at the middle octet. Remember something like this. මෙතන තමයි separation එක කරන්නේ. So then we can create 2 to the power 16 networks like that. That is 65,536. And each network will have again 65,536 machines. And if it is class C, we break it in the third octal, net ID versus host ID. So therefore, this is 24 bits and this is 8 bits. So now each network can have only 256 machines. But we can create 16 million such networks. Can කවුරු හරි කිව්වොත් මට network එකක් හදාගන්න ඕන. මට ඕන machine 10යි කියලා. machine 10ට වැඩි මට ඕන වෙන්නේ නැහැ මගේ network එකේ කියලා. අපිට පුළුවන් යාට class C IP address එකක් දෙන්න. මොකද එයාට යන්න පුළුවන් machine 256ක් වෙනකම්. අපිට ඒ වගේ මිලියන 16ක් network වලට අවස්ථාව තියෙනවා. මේ මිලියන 16න් එකක් එයාට දෙන්න. ISP provider. ඒ මුළු ලෝකෙටම තියෙන මිලියන 16ක්. ඒ වගේ network. If someone says, I need to create a subnetwork and each machine needs IP addresses, my subnetwork need 1,000 machines. ටිකක් ලොකු company එකක් වගේ. Forget about 1,500 machines. So then we can't use class C because class C IP address, the separation is here. You can go maximum 256, but this guy needs 500. So then we need to assign a class B IP address. හැබැයි මේ IP address ලෝකෙටම තියෙන 65536යි. ඒතකොට ඒකයි කතාවේ මේ දෙන්න හදන්නේ. මේ machine 500 IP network එක. You can see that this approach is very rigid and we waste a lot of IP addresses. Because when someone needs 10 machines, we give 256 IP addresses. We assign block of 256 IP addresses. When someone needs 500 IP addresses, now we can't assign a class C, but we assign a class B IP address. But this guy gets 65,536 IP addresses. So almost 64,000. Right? If this guy needs 500 IP addresses, basically 65,036 IP addresses are wasted in this approach. But anyway, it is not waste because we can further subdivide. So rather than we give it to, say, X person, right? We collect set of people and assign it to those set of people and let them subdivide it among themselves. So that is the idea. So therefore, don't think that we waste something like huge number of IP addresses. We can collect those guys and assign and then let them subnet. So we can facilitate the subnetting further. So that is the idea behind subnetting. So that means we create a subnetwork and that subnetwork we can further subnetwork. And that subnetwork we can further subnetwork. එතකොට ඒ වගේ යාට අවශ්‍ය ගන්නට තියෙන කොටස විතරක් යාට දෙන්න පුළුවන්. If someone needs only 10 IP addresses, IP address 16ක subnetwork එකක් විතරක් යාට දෙන්න පුළුවන් අපිට. අර වගේ 256 1000 ගණන් වල ඒවා දෙන්න. Because the subnetting concept can be extended because remember earlier we had two portions. Net ID, host ID. So the idea is when you have the net ID and host ID, we can borrow some bits from the host ID and create a subnet ID. Then your network is getting smaller, but you can create subnetwork. So that can be further subnetwork, further subnetwork, further subnetwork. Okay, so that is how we create network into smaller networks, and that network into further smaller networks, and that network into further smaller networks, and so on, using this concept of subnetting. Okay. Right. So there's a typing mistake here. I just now found it. Uh, I will fix it and re-upload. So as a solution, uh, classful, not classful, classless. As a solution, classless subnetting was introduced. Okay, so it's a big mistake actually. Completely opposite thing has been typed. Okay, classless. I will re-upload it. Okay, later. Right. So don't worry too much about classless right now. Let's concentrate on classful subnetting for the time being. Okay. But you must know the idea. Now you can subdivide you can borrow some bits from the host ID to create subnet ID. And if, in the future, we can further borrow a few bits from the host ID and create it, because maybe now we can create 64 host, but we just need, rather than having 64 hosts in the same network, I want to create two networks with 20 each. So then we can further borrow 1 or 2 bit and make it into a further subnetting. So theoretically, we can go into maybe just one computer network වෙනකම්ම යන්න පුළුවන්. ඒක computer network එකෙන් පස්සේ ආයි subnetting කරන්න ඕනේ නැහැ. ඒ වගේ ඔයාලට පොඩි ඔයාලට අවශ්‍ය කරන නවත්තන්න පුළුවන්. හරි. 8 subnet දෙකක් තියෙනකොට අපිට පුළුවන් ඔන්න එක 8 subnet එකක් අරගෙන 3 subnet දෙකකට කඩා ගන්න ඕනලා. හැබැයි එකකට ගියාට පස්සේ ඔක ආයි කඩන්න දෙයක් නැහැ නේ. ගොඩක් කට්ටිය එකක subnet හදන්නේ නැහැ නේද? අඩුම ගන්න subnet එක machine දෙකක් තියෙනවා. තනියෙන් subnet කරගෙන ඉන්නේ නැහැ නේ. Okay. So again, this is, you must have now thousands of questions. Questions actually I have done a wonderful job. Or you are very genius person, or both. Or else you must be having hundreds of, now you must be having hundreds and thousands of questions in your mind, which you need to resolve by asking questions, doing searching, read further, and so on. දැම්ම සබ්නෙට් ඉගෙන ගන්න පටන් ගත්තොත් එක්සෑම් ලඟ වෙනකොට සෑහෙන අවබෝධයක් තියෙනවා. එක්සෑම් එකට සති දෙකකට කලින් සබ්නෙටින් නෝට් එක දිගහැරි අරින්න ඊළඟ අවුරුද්දේ එක්සෑම් එකට යනවා අනිවාර්යයෙන්. කිසි සැකයක් නැහැ. මොකද මේක සතියෙන් ඔලුවට වදින සබ්ජෙක්ට් එකක් නෙමෙයි. Right. So any questions up to this point? Now you know that we can subdivide any valid IP address into two parts. Host ID, sorry, net ID, host ID. Okay. Now there's another concept. Now assume that my net ID has 32-bit, host ID has, remember altogether, sorry, not 32-bit, altogether 32-bit, right? So therefore, let's say we have 24 bits, and the host ID I have 8 bits. So that means I can create 2 to the power 8 bit patterns here, because these bit patterns are for host IDs. We have the flexibility to change these bit patterns, but each and every machine in that network, subnetwork, this particular bit pattern is not changed, because it's a fixed. Net ID is fixed now. ඒක මොකක් හරි දැන් මේ වෙද්දි bit 24ක නම්බරයක්. ඒක තමයි ඔයාලට දීලා තියෙන්නේ. ඒක වෙනස් වෙන්නේ නැහැ ඔයාලට. ඒක හරියට ඔයාගේ ගෙදරට බිල්ඩිමට 35 නම් ඔයාගේ එක එක ස්ටෝර් ගෙවල් වලට එන්නේ 35න් 1, 35න් 2, 35න් 3. ඔයාගේ ඊළඟ ගෙදරට හම්බ වෙන්නේ 45න් 1 කියලා. මොකද ඔයාලට බිල්ඩිමට දීලා තියෙන්නේ 35. So therefore, this net ID is now fixed. But host ID you can change. හැබැයි මේ වගේ වාඩි ඕන ගානක් දාගෙන යන්න නැත්නම් මෙතන bit ප්‍රමාණයක් වාඩි දීලා තියෙනවා. මේ bit ප්‍රමාණය අපි හිතමු 2යි කියලා. 1යි කියලා එහෙනම් වාඩි 35න් බිංදුව 35න් 1 කියලා 35න් 9 වා නවතින්න ඕනේ. වාඩි bit දෙකක් දීලා නැත්නම් ඉලක්කම් දෙකක් දීලා දෙනොත් බිංදුවයි බිංදුව බිංදුව 1 කියලා 99 වෙනකම් දාන්න පුළුවන් ගෙවල්. ඒ වගේ තමයි bit ගාන වැඩි කියන්නේ. When you have more bits, you have more possibilities of having host. Lesser bits means you have lesser number of host IDs. But this one is fixed to you. මේක හරියට කතන්දරේ තේරුම් ගන්න. සමහරවිට තේරුණා කියලා හිතනවා ටිකක් වෙලා ගියට පස්සේ එනවා. මේක ටිකක් මඤ්ඤම් වගේ කියලා. පුළුවන් තරම් practical exams වලින් හිතන්න. සාමාන්‍ය ලෝකෙදී මේ වගේ මේ ගෙදරකට නම්බර දානවා වගේ. Right. So now if for example if this is example, so if you have 24-bit 8-bit separation, so host ID 24 bits, net ID 8 bits. So theoretically you can create 2 to the power 8 host numbers because from 0 0 0 0 0 0 8 zeros to 1 1 1 1 1 1 1 1 is, so those are all possibilities. Okay, those are all possibilities. So if you have something like say 28, then 4 bits, right? 28 and 4 නම් ඔයාලට තියෙන්නේ. එහෙනම් ඒක කීයක් තියෙනවද? So then 2 to the power 4 possibilities for host ID. That is 16. Okay. So now we have another, not a problem, another concept. That is when you are assigned IP address ranges like separating like this, 2 of the IP addresses are reserved. A IP address එක reserve කරන්න ඕනේ. ඒ දෙක දෙන්න බෑ host ලාට. Host කියන්නේ machine එකකට. So that means the first IP address in the range, that is when all host ID bits are 0. And the last IP address in the range, that is when all host parts are 1s. If it is 4-bit, all 4 bits are 1. And this IP address is reserved and all 0 IP address is reserved. So all 0 means only for the host side, host part. Because all 0 IP address is reserved as the net ID or the network ID. ඒකෙන් තමයි network එකේ IP address එකක් කියලා එකක් දෙනවා. අර මෙතනට 35 කියලා දුන්නා වගේ. So therefore that IP address you can't assign to a machine. මේ 00 තියෙන IP address එක ඔයාලට machine වලට address දාන්න බෑ. But 00001 එකේ ඉඳන් ටික දාන්න. And again this all one part address is reserved as broadcast ID or broadcast address. So therefore you can't assign that to any machine or any host. So therefore effectively, if you have n bits for the host side, you have 2 to the power n IP addresses. But how many hosts you can have? 2 to the power n minus 2. Because 2 of the IP addresses, that is this, all 0 IP address and all 1 IP address is reserved for host ID, net ID and broadcast ID. Okay. So therefore, if someone asks how many IP addresses are available, 2 to the power n. If someone asks how many hosts you can have, 2 to the power n minus 2, because 2 of the IP addresses are reserved. Right. I hope you can understand what is subnet address, because that address is used to identify your network. Okay. ඒ කියන්නේ මෙතන ඔයාගේ බිල්ඩිමට දාපු නම්බරේ 35 නම් ඔයා කිසිම ගෙදරකට දාන්න එපා 35 කියලා. ගෙවල් වලට දාන්න 35න් 1 35න් 2 35න් 3 35න් 4. ගෙදරකට දාන්න එපා 35 මොකද 35 කියන්නේ බිල්ඩිමේ නම්බරේ නැත්නම් වත්තේ නම්බරේ. So something like that, the net ID. Right. So then why do we need a broadcast ID? Broadcast ID. So broadcast ID is something like if a machine in this subnetwork need to send a message to all the machine in that subnetwork, all the machine. So then rather than it send the message to the each and every IP address in that range, it will send that message to the broadcast IP address. මේකට තමයි යා message එක යවන්නේ. මේකට යවම route එක දාන්නවා ඒ subnetwork එකේ ඉන්න හැමෝටම මේ message එක යවන්න. ඒක හරියට අපි හිතුව මෙතන 35න් එක 35න් අපි හිතුව 35න් බිඳුව කියන එක රිසර්ව් කරලා නැත්නම් 35 කියන එක රිසර්ව් කරලා තියෙනවා බිල්ඩිමට. දැන් 35න් 1 2 3 4 කියලා අපි 35න් 9 අපි 10 නැහැ කියමු. අපි හිතමු 35න් 9 කියන එක රිසර්ව් කරලා තියෙනවා. කවුරු හරි 35න් 9ට ලියුමක් එවුවොත් එහෙම 35න් 9ට ඇත්තට මේක එළියෙන් නෙමෙයි මේක ඇතුලේ වෙන වැඩක්. මෙයාට පුළුවන් මෙයාට ලියුමක් යවන්න. 35න් 1ට පුළුවන් 35න් 3ට ලියුමක් යවන්න. 35න් 2ට 4ට පුළුවන් 35න් 8ට ලියුමක් යවන්න. අපි හිතමු 35න් 2 ලියුමක් යවනවා 35න් 9ට. ඒ කියන්නේ ඇතුලේදී අපි හිතමු ඇතුලේ කවුරු හරි සිකියුරිටි කෙනෙක් ඉන්නවා කියලා. එයා 35න් 9ට ලියුමක් යවලා තියෙනවා නම් කවුරු හරි ඒ ලියුම කොපි කරලා හැමෝටම යවනවා. මේ බිල්ඩිමේ ඉන්න හැමෝටම යවනවා. බිල්ඩිමේ ඉන්න අයට. So that is what is meant by broadcasting. So then someone will ask, of course, if you are a critical thinker, why do you want to send something to all? ඇයි මම මේ හැමෝටම ලියුමක් යවන්නේ? හරි අපි හිතමු ආගේ මොකක් හරි නෝටිස් එකක් තියෙනවා කියලා. ඔයාලට මේ හැමෝටම නෝටිස් එකක් දෙන්න ඕනේ. ප්‍රෙස් වීමක් තියෙනවා. පහු මේ බිල්ඩිමේ අයගේ. ඒකට හැමෝටම යවන්න ඕනේ. හැමෝටම යවනකොට ඔයා යවන්නේ මෙතන නම් 35න් 9ට තමයි යවන්නේ. එතකොට security දන්නවා 35න් 9ට යවුවයි කියන්නේ මේක හැමෝටම යවන්න ඕනේ. So similarly, if a machine want to send some message to all the machines in that subnetwork, it send that data packet to this particular IP address, broadcast IP address. That is the last IP address in the range. So then your router knows that it must be sent to each and every machine in that network, in that subnet. That is why 2 IP addresses are reserved. So therefore, the number of IP addresses minus 2 is the number of hosts allowed. Okay. Any questions? So now we are into that, the all important part. ටික ටික අර වැදගත්ම calculation තියෙන හරියට දැන් එනවා. Okay, so let's do an example. Let's do an example. So example 1. The host node is given 167.199.170.82/27. I will explain this slash notation. Okay. Find the network ID, broadcast ID, number of hosts of the subnet that host belong to. This is IP address of one particular host. So the examiners can give you large number of different type of questions, challenging questions. So this is one type of question. Okay. So this is an IP address of a particular host, one host in that network. So there will be some other host also in that network. Say it's network like this. We don't know how many. Okay. This is the router. So you know that usually the router is assigned that subnet ID. Okay, subnet ID ගොඩකට assign කරන්නේ ඒ IP address එකක් නේ එකත් ඒක assign කරන router එකට ගොඩක් කරා. And one of the machines IP address මේ එකක IP address එක තමයි ඔයාලට මේ දීලා තියෙන්නේ. What is that IP address? 167.199.170.82/27. So this slash notation is called CIDR notation. So there's another notation called subnet mask notation. Still, we have not discussed about the subnet mask. So just remember, this is the separation point. Remember, we can subdivide it into 2 parts. Net ID, host ID. So /27 means your separation from net ID to host ID is at the 27th bit. That is 27 bit here, altogether 32. Right? So therefore 5 bits in the other side. That is how you start. Right? It's 27 and 5 bits because separation is at the 27th bit. Okay. And you know that 5 bits in the right hand side means that separation is in the last octal. අන්තිම bit අටේ තමයි ඔක වෙන්නේ. මොකද bit 5යිනේ. ඔක bit 10ක් වුණා නම් දෙවෙනි bit අටේ වෙන්නේ. So therefore, you don't need to convert these numbers into binary because the separation happens in the 5th bit, right? Sorry, 27th bit. But therefore, you just need to convert this 82 into bit binary. Right? If you convert 82 into binary, 41 0 remains, 21 remain, 10 0 remain, 5 0 remain, 2 1 remain, 1 0 remain, 0 1 remain. So that is 1 0 1 0 0 1 0. Okay. 1 0 1 0 0 1 0. That is 7 bit. 1 2 3 4 5 6 7. So you need to add another 0 to the left because otherwise you change the value. So basically, 82 is this. Of course, you don't need to convert these into bits, though I have just converted for your information. Okay, so that is not required. You can just say 167, 199, 170, but this 82 is this. And because this is /27, the separation is after 8, 8, 8, 24, 5, 6, 7. So this is where the separation. So from this point, left side is net ID, right side is a host ID. And this is one of the machine, right? A host node. This is one of the machine. Or IP address of one of the machine in that subnetwork. So the question is, find the network ID, broadcast ID, and number of hosts. Now, if you want, you can straight away calculate the number of hosts because we know that it is 27 and 4. Sorry, 27 and 5. So that means we have 5 bits for the host. So if you have 5 bits for the host, how many bit patterns are available for host? 2 to the power 5. That is 32. So that is 32 IP addresses are available for this subnetwork. But out of these 32 IP addresses, 2 is reserved. 2 IP addresses are reserved. So the question is number of hosts. So number of hosts means 32 minus 2 because 2 IP addresses you can't assign to host because that will be the subnet ID and the broadcast ID. So therefore, there is a possibility of 30 number of hosts. 30 number of hosts in this particular subnetwork. So that part already done. So then we need to find the network ID and broadcast ID. Remember, this is one of the machine's IP address. Right? So remember, the first IP address is the subnet ID. So the first IP address is when all these bits are 0. And this is one of the possibility. All these bits are 0, but you can't touch the rest of the stuff. Because that is fixed. ඒක හරියට අපේ ගෙදරක නම්බරේ දැන් දන්නවා මේක 43න් 6 කියලා. එහෙනම් මේ බිල්ඩිමේ නම්බරේ 43. ඒක වෙනස් කරන්න බෑ ඔයාලට. මෙතනින් මේ පැත්ත. ඒ දැන් මේ පැත්ත තමයි මේකේ බිඳුව තමයි බිල්ඩිමේ නම්බරේ මේකේ 9 තමයි අපි එකයි කියලා ගත්තොත් broadcast. So therefore don't change this part 0 1 0. When you have all zeros, that will be your first address or the subnet ID. When all these are ones, but don't change the rest of the stuff because that is belonging to the net ID part. So that will be your broadcast ID. And remember, these things are not changed. 167, 199, 170. Right? So that is not changed. So then what is this number? 1, 2, 4, 1, 2, 4, 8, 16, 32, 64. So therefore, this is your subnet ID because this is the bit pattern. And what is the broadcast ID? 0, 1, 0, all 1. That is 1 plus 2 plus 4 plus 8 plus 16 plus 64. And it will be 95. Right? And that is your broadcast ID. That is the broadcast ID of the network, subnetwork, this particular host belong. And therefore, we got the 2 answers. How many hosts? 30. Network ID is 167.199.170.64. Broadcast ID is 167.199.170. This number, which is 95. And this is within this range. මේ 64යි 95යි අතර තියච්ච නම්බරයක් දැන් 82 ඒක තමයි මෙයාට මේ මැෂින් එකේ නම්බරය. So likewise 167.199.170.65 is assigned to another machine. 66, 67. Right? So 82 is assigned to this machine, then 83, 84, and we can go up to 94. So that is why we have 30 host IDs out of 32 IP addresses available. Any question? Any questions up to this point? Anything not clear, or you feel like one is conflicting with other? මම කලින් කිව්ව එකත් දැන් එකත් එක්ක conflict වෙනවා නම් එහෙම නැත්නම් exam එකේ question ආව විශේෂ MCQ දෙනවා මේ වගේව අනිවාර්යෙන් කරන්න ඕන. එහෙම නැත්නම් දැන් ප්‍රශ්න තියෙනවනේ මේ වෙන්නේ. Right. So no.
Sir, I explain කරන්න පුළුවන්ද?
මොකද්ද?
Sir, I example එක explain කරන්න පුළුවන්ද?
මම ඊළඟ example එකක් ගන්නකොට ආයි explain කරනවා. හරි. එතකොට ආයි තව මේ වගේ question කරන්න. Right. So this is the second example. The main example එකේ ආයි මේක explain වෙනවා. Right. But this is slightly different example. Given the IP of a host machine in a network as, so this is one of the machine's IP address, okay? Again, this is one of the machine's IP address in a subnetwork. That IP address is 192.100.12.200. And this time it has not given it as a slash number. 192.100.12.200 is the IP address, and the subnet mask is 255.255.255.224. So the question is, find the network ID, broadcast ID, and number of hosts of the subnet that this host belong to. Okay. So what is mean by subnet mask? Okay, what is mean by subnet mask? So there are two. Actually, I want to explain you a few theory part before coming to this question. Okay. So there's a concept called default mask. And there's a concept called subnet mask. Default mask, subnet mask. Okay. For example, when I type this, right? So this is my IPv4 local IP address, 192.168.110. And below you can see there's something called subnet mask. And understanding subnet mask is another very important concept. If you want to really understand how the things are happening inside, ඇතුලේ කොහොමද වෙන්නේ කියලා තේරුම් ගන්න නම් නැත්නම් මේකේ තියෙන තියරි එක හදා තේරුම් ගන්න නම් සබ්නෙට් මාස්ක් එකක් කියන්නේ මොකක්ද කියලා තේරුම් ගන්න. Okay. So this is the subnet mask. Okay. And then we have a concept called default mask. Subnet mask, default mask, just two different words. Okay. Right. So basically, subnet mask is another way of telling where is the separation. Right? Where is this separation? What is that? Which separation? The separation between net ID and host ID. Net ID and host ID. So therefore, don't think that this is IP address. This is not at all an IP address. This is I don't know why they use this concept. A complicated way of telling what is the separation point. As simple as that. මේ separation point එක හෙන්න complicated විදියට කියන විදිය. ඒක මහා complication නෑ. නමුත් අපි පටලවන විදියට කියන විදියක්. ඉතින් එහෙම තමයි ඉස්සර ඒගොල්ලෝ කිව්වේ. Subnet mask. So the subnet mask is, though it looks like IP address, it is not IP address. Okay. And here you can see it's all 255, 255, 255. That means 8 ones, again 8 ones, and again 8 ones. So then if you convert 224 into binary, of course you need to do it. 224 into binary. 1120. 56 0. 28 0. 14 0. 7 0. 3 1. 1 1 0 1. So therefore, this is all ones, right? So this one is basically 1 1 1 and 5 zeros. 1 1 1, 5 zeros. So basically, if my subnet mask is 8 ones, 8 ones, 8 ones, and 3 ones and 5 zeros, this is where the separation of net ID to host ID. Separation that means after 8, 8, 8, and 3. That is 8 plus 8 plus 8, 24, 5, 6, 7, 27. So here you have 27 bits. Here we have 5 bits. In other words, giving you the IP address and subnet mask is like this is same as giving this as /27. So rather than giving it as /27, that is the previous example, right? The new approach. The old approach is you give the IP address and subnet mask. So basically, subnet mask is a way of telling where is the separation point. Where is the separation point? Okay. And you can see it's a very odd way of telling. And one thing is sometimes students get confused that this is IP address. This is not IP address. This is just a way of telling you where is this separation point. The old way of telling where is this separation point. Okay. So now you know that the IP address is 192.112.200 and its net ID to host ID separation happens in the 27th bit that we took it from this subnet mask. Okay. Now from this point onward, this question is just like the previous question. Just like the previous question. And this is IP address of one of the machine in that network, right? One of the machine. So now you know that again, this separation happens in the last octal because 5 bit. So then the last octal separated the 8 bit. So therefore, I am not interested in converting these into binary because the separation occurs in the last octal. So therefore, I will be converting only 200 into binary. If I got something like 20 here, then of course, I need to convert this also into binary because if it is 20, we have 12 bits here. 12 bits means 8 plus 4 bits. So 8 bit is here, other 4 bit here. So then I need to convert both into binary, but here it's 5 bit. I'm only interested in converting 200 into binary. So therefore my number is, number of this IP address of this particular host is 192.112. This part I want to convert it to binary because this is where all these things are happening. Okay. And so let's convert 200 into binary. 100 0, 50 0, 25 0, 12 0, sorry, 12 1. If I make a mistake, just let me know. 6 0, 3 0, 1 0, sorry, 1 1, and 0 1. That is 1 1 0 0 1 0 0. How many bits? 1 2 3 4 5 6. Yeah, all 8 bits are there. 1 1 0 0 1 0 0 0. And we know that this separation is at the 20 after 27 bit. 8 8 8 24 5 6 7. Just 3 more bits we need to take. 8 8 8 24 5 6 7. So separation happens here. Separation happens here. And this is one of the, remember this bit pattern is for host IP addresses. This bit pattern is for net ID and it is now fixed because this is for one particular subnetwork. Okay. So therefore, what is the first IP address in that range? This is not going to be changed. So the first ID will be 192.112. These bits we can't touch because this is net ID 110 and all others are 0. 5 zeros. 3, 5, 6, 7, 8. And the last IP address, so this will be our net ID for this particular network having this machine. The last ID or the broadcast ID will be broadcast 192.100 because these bit patterns are not going to be changed. 110, others are 1. Okay. So therefore, first of all, how many hosts will be there in this network? Because we have how many bits to play around? Other than 32 minus 27, 1, 2, 3, 4, 5. So therefore, how many bit patterns are possible? 2 to the power 5. But this IP address and this IP address is reserved for net ID and broadcast ID. So therefore, how many possible hosts like this? Other 22 to the power 5 minus 2. Again, it is 30. 30 hosts can be allocated. So then what is the subnet ID of this network? All 0. 1, 2, 4, 8, 16, 32, 64 and 120. 64 plus 128. 192. So the subnet ID is going to be 192.112.192. That is one answer. And what is going to be my broadcast ID? 1, 2, 4, 8, 16, 32, 64, 128. So that IP address is the broadcast ID. You can't touch this, okay? So therefore, this is 0. So that is 128 plus 64 plus 16 plus 8 plus 4 plus 2 plus 1. This is 10. This is another 10. That is 20, 28, 32, 33. 3. 3 plus 1, 4. 4 plus 6, 10, 12. 2, 2, 3. So the broadcast ID is going to be 192.112.223. So the broadcast ID of the subnetwork having this machine will be this IP address. Okay. And it is going to have 30, altogether 30 host machines. 192.223 and 30 number of hosts. So it's very important that you understand where is this separation. So either they can just give it like this, CIDR notation, or they will give IP address of a machine and subnet mask. So subnet mask effectively tell you where is this separation. Okay, where is this separation? Are you still having confusion? If so, you need to ask me specifically. I don't understand this particular part. Okay, so then I can explain. When මේ කියලා හරියට specific question එක આવුත් මට දැන් I can again explain it. I can again explain it. Or you need to ask why do we do that? And then specifically question එක අහන්න ඕනේ එතකොට තමයි උත්තර දෙන්න. Because I explained it for the second time also now. Anyone having questions? Because it's super important you understand this. තාමත් තේරුම් නැත්නම් right, go to ChatGPT, and ask ChatGPT steps එක දෙයි මේවා කරන විදිය. Okay. For example, go to YouTube and watch some recordings. සමහරවිට recordings බලනකොට මේ තේරිච්ච එකක් confuse වෙන්න පුළුවන්. මොකද සමහරු කන්නේ තේරුම් ගන්න එක නෙමෙයි confuse කරන එකනේ. බලන්න. ChatGPT එක අහලා බලන්න. බොහෝ විට හරි උත්තරේ දෙයි. මම explain කරපු විදිහට නෙමෙයිද බලන්න explain කළා තියෙන්නේ. So number of host 30. හරි දෙකක් අඩු කරාය. හරි ඊට පස්සේ මේ bit patterns එක අරගෙන එයාර අන්තිම bits එක 0 කරලා අරගෙන තියෙන net ID එක 192 number. හරි. අග ටික ඔක්කොම 1 කරලා හදලා තියෙනවා 223. So 192 number 192 and 223. Those are the two values we got, right? 192 223. ඉතින් දැන් ඔයාලට ඕන තරම් ඉන්නවා උදව් කරන්න. හරි. අපි නැහැ කියලා බය වෙන්න එපා. හරි. දැන් බය වෙන්න දෙයක් නැහැ. AI ආවට පස්සේ ප්‍රශ්න විසඳ ගන්න හරි ලේසි. මිනිස්සුන්ගෙන් අහම මිනිස්සු වෙන බයිලා ගහනවානේ. AI වලින් බයිලා ගහන ප්‍රමාණය අඩුයි. හරියටම කියයි. කතන්දරෙත් කියලා හේතුවත් එක්කම කියයි. Right? To find the network ID, broadcast ID, and the number of hosts in the subnet, you will need to perform some calculations based on the given IP address and subnet mask. Right? So network ID, to find the network ID, you perform bitwise and operate. ඒක ටිකක් ඇඩ්වාන්ස් කතාවක්. ඒක ඇතුලේ වෙන වැඩක් ඔය කියලා තියෙන්නේ. ඒ කියන්නේ දැන්ට හොරි වෙන්න එපා. මම ඒක කිව්වේ නෑ ඔයගොල්ලන්ට. ඒක පස්සේ මම එක්ස්ප්ලেইন කරනවා හැබැයි. හරි? මොකද ඒ කතාව කිව්වොත් එimhe ඔයගොල්ලෝ තවත් කන්ෆියුස් වෙනවා මම කිව්වේ නෑ. හරි? මේ කතන්දරේ ඔයාලට දැනට ඕනේ නෑ මේ කැල්කියුලේෂන් එකට. මේ ඇවිල්ලා ඇතුලේ වෙන වැඩක්. Inside your routers, how they do this, how do they calculate this? Okay, how do they calculate the subnet ID? How do they calculate the broadcast ID using a logic, right? Boolean logic operations rather than ඒ කියන්නේ අර ඔක්කොම බින්දු කරනවා සහ ඔක්කොම එක කරලා ඉවරලා අර calculate කරපු එක එයා calculate කරගන්න වෙන විදියක් තමයි ඔය කිව්වේ. හරි ඒක ගණන් ගන්න එපා. Right, so then so convert the IP and subnet mask to binary. එතකොට ඔන්න IP address එක binary කරා. හැබැයි මේ හරි කරන්න ඕනේ නැහැ ඇත්තටම. හරි. මේ තුන ඕනේ නැහැ. So then subnet mask. So මේ okay. So ඊට පස්සේ යා මේ අර ඇතුලේ වෙන විදියට තමයි subnet ID එකයි broadcast ID එක හොයලා තියෙනවා. නමුත් ඒක අතරේ හරි. මේ තියෙන ඔක්කොම ටික 0 කරලා තියෙනවා. ඔක්කොම ටික 1 කරලා තියෙනවා. මේ තුන 0 කරලා ගත්තා. මේ ටික 1 sorry මේ 5 0 කරලා ගත්තා. මේ 5 1 කරලා ගත්තා. එතකොට ආර උත්තර දෙක ඇවිල්ලා තියෙනවා. The two values, that is 192 and 223. Right? So this is 192. When you make these 5 zeros, then when you make those 5 ones, so this is making those 5 zeros, but without changing 110 because that is IP address of that machine. Right? So don't change the 110, but change rest of the stuff to 1. Okay, right? That is how you do it. බලන්න I note එක කියලා බලන්න තේරෙන්නේ නැති දෙයක් තියෙනවා කියලා. Okay. Right. So before moving to the, now you should be able to do the exercise 3 and exercise, of course, exercise 3 I will be doing. Okay. But this is because that is something I want to do with you guys. So this is actually exercise 1, this is exercise 2. Exercise 2 I will do with you. But before coming to that exercise 2, I want to explain you something about subnet mask and default mask. Okay, default mask and subnet mask. So then I will come back to this example. Okay, චූටි break එකක් අරගෙන ඒක explain කරන්න. පොඩි break එකක් අරගෙන. So now it is 10:25. We'll be starting at 10:35. Just 10 minutes. Okay. Then I will explain what is subnet mask and what is default mask. Okay, so let's continue. Right, so now let's look at what is this default mask and subnet mask. So default mask is related to classes. Therefore, now we are going back to the classes. I told you that we have three classes, actually 5 classes. Out of those 5 classes, for subnetting, we use only 3 classes. Okay, that is class A, class B, and class C. Okay, so in class A, remember that we have 2 separations now. Net ID, host ID. Oh, host ID part, net ID part. That is a better word. So in class A addresses, it is somewhere here. 8-bit, 24-bit. In class B addresses, it is middle. 16, 16. In class C addresses, it is 24, 8. And that is something we all know. That is how they have come up with class A, class B, and class C. Okay. 8, 24, 16, 16, 24, 8. Right. So another way of saying where is the separation is by using the concept called default mask. Right? Default mask. Right? So we say that for class A addresses, default mask is 255 0 0 0. For class B addresses, the default mask is 255 255 0 0. For class C addresses, the default mask is 255 255 2550. Okay. So this is just another way of saying the separation is at after 8-bit, after 16-bit, after 32-bit. So basically 255000 means 8 ones followed by 24 zeros. Right? 8 ones followed by 24 zeros. So 255255000. So 2552550 means 8 ones, another 8 ones, that is 16 ones, followed by 0 means 8 zeros. In binary, 0 means again 8 zeros. That is 16 ones followed by 16 zeros. So when we say 255255250, it is 24 ones followed by 8 zeros. So basically, this net ID to host ID separation is where your ones are ends and 0 starts. So in this case, 8 ones and then 24 zeros. So that therefore, basically, when we say 255000, it means the separation is at the after 8-bit. When we say the default mask for class B is 2552550, it's another way of saying it is separation is after 16-bit. When we say class C default mask is 2552550, it's another way of saying the separation is 24-bit and 8-bit. So therefore, this concept of default mask is just another terminology. It has no other meaning. And this default mask is not an IP address. Default mask is a way of telling where is the separation. Actually, you don't have to, no one need to tell it to you, because we all know that for class A, it is 8 and 24. Or in other words, for class A, default mask is 255000. And class B separation is at the middle. So in other words, we must know that the default mask for class B is 255 25500. For class C, separation is after 24 bit. So therefore, class C IP addresses default mask is 255.255.255.0. Any class C address, okay, any address, right? Any class B address, the default mask is 255.255.0.0, or separation is at the 16 bit. Okay. So therefore, we have only 3 default masks. What are the 3 default masks? 255.0.0.0, that is the default mask for class A IP addresses. 255.255.0.0, that is the default mask for any of the class B addresses. 255.255.255.0, that is the default mask for any of the class C addresses. So therefore, usually no one must give you the default mask, because by looking at the IP address, you need to determine whether it's a class A, class B, or class C. Then you must know what is the default mask. If it is class A, default mask is 255.0.0.0, class B 255.255.0.0, class C 255.255.255.0. So other than that, this concept of default mask has no other meaning. Okay. Or you can just forget about the concept of default mask and just remember class A address where the separation, class B address where the separation, class C address where the separation. But this concept of default mask is a standard terminology in networking. So therefore, you must be aware of this word, though we will not be using that word much. Okay, so that is called what? Default mask. So there are only 3 default masks. That is 255.0.0.0, 255.255.0.0, 255.255.255.0. Only 3 default masks are available in networking, IPv4 networking. Okay. Right. So next, what we do is, I told you, if you go by this default mask concept, we waste a lot of IP addresses. We waste a lot of IP addresses, because when you need 4 IP addresses, we are giving you 256 IP addresses. That is 2 to the power 8 IP addresses. Okay. When you need 500 IP addresses, we are giving 2 to the power 16 IP addresses. So that is where this subnet concept came. Okay, subnet concept came. So that means we can borrow some bits. For example, let's say I have a class. Let's say I have a class. Yeah. So let's say I have a class C IP address. Okay, class C IP address. So in class C IP address, this separation is after 24 bit. So 24 here, 8 here. But I need only 10 host IP addresses. I need only 10. But how many IP addresses I got for this block? 256. Of course, out of 256, I can use only 254 because 2 IP addresses are reserved. But I don't need 254, I need only 10. So then what we can do is, we can break it into a smaller subnetwork, where I can use only 10 IP addresses for my network, and then the rest of the stuff can be used for other subnetwork. Rather than we create one subnetwork, we can create several subnetworks. So that is better use of IP addresses. So therefore, this separation is something determined by your class. Okay, or default mask. Class A, this is at 8. Class B, this is at 16. Class C, this is at 24. Right? So either it is implicit, or someone can say, okay, default mask is 255.0.0.0. Default mask is 255.255.0.0, or default mask is 255.255.255.0. But no one need to tell it, because we know that class A, what is the default mask, or what is the separation point? Class B, what is the separation point? Class C, what is the separation point? So then, so the class will determine this point. But when we borrow some bits from host side to break it into smaller subnetworks rather than using that big subnetwork, so that is where we have the subnet ID part. So this is network ID, this is subnetwork ID part. But in reality, this all together is called the subnet ID. you can look at it as network ID and subnet ID, but usually this is the subnet ID. Okay, it's something like 45/3, but this is the subnet, the house number, but overall the house number is 45/3. Now, how do you tell? How do you communicate? Where is this point? Where is this point? The separation between subnet ID and host ID. So there are two ways. So we used both the approaches in the previous two examples. One approach is slash notation. Say 200, say 35, 105, 80 slash, let's say 28. Sorry, let's say 30. So that means, so the slash notation is used to denote this point. By looking at the class, we know what is this point. Okay. By looking at the class, you can determine the class by looking at the first number. Now this 30 is, this subnet to host separation is after 30 bits. After 30 bits. So this is 200 IP address, right? So 200 IP address is what class? So 200 IP addresses are class C, right? 192.223. Okay, so it's a class C IP address, and because it's class C IP address, so now I can even write the separation because it's a class C IP address. So this separation is after 24 bit. That we know because we know the class of the IP address. By looking at the first part of the number, I know the class of that IP address. So therefore, this separation is at 24. Or I know that though someone has not given to me, this IP address default mask is, because this is class C, 255.255.255.0. Or in other words, net ID to host ID separation is after 24 bit. So then this part says, this is net ID and host ID. We can borrow it. They have borrowed few bits for the subnet ID. That is why it is not 20/24, rather it is 30. If this is /24, you have not borrowed anything from the host part. But this is 30, whereas this separation is 24 because this is class C. So that means this is after 30 bit. So after 30 bit, you have this separation. That means it has taken 6 bit here. 24 plus 6 is 30. Then we have 2 bits here. So therefore, by looking at this /30, I know that my net ID take 24 bit, subnet ID takes 6 bit, because 24 plus 6 is 30. This 30 says this separation point, and of course 2 bit is available for the host. Okay. Have you got it? So therefore, this margin is determined by your class. Right? This margin is determined by your class. Or implicitly by default mask. This margin is what you have been, what someone need to give it to you using this notation. Okay. Or else, either you can give this margin or number of bits here using this slash notation. We call it CIDR notation. Or else, this margin can be given using subnet mask. Okay, that is not default mask. Using subnet mask. Right, something like 255, 255, 255 something. And your subnet mask must be always, when you convert to binary, set of ones followed by set of zeros. So here you can't have zeros, all ones. One zero start, all zeros. Right. So your left side must be all ones, right hand side must be all zeros. You can't have any combinations like after 1 0, there can't be 1. Okay. When there are ones, all ones, once zero start, it must be all zeros. then only it is a valid subnet mask. Otherwise, it is not a valid subnet mask. And this separation point, when you convert your subnet mask IP subnet mask into binary, this separation point determines this subnet to host separation. Okay. So therefore, rather than 30, someone will write it as 255, 255, 255, and a number which represent 5 ones and 3 zeros. මෙන්න මේක 10 පාදයට හරවලා එන නම්බරේ බෙදන්න දෙන්න පුළුවන් වගේ සබ්නෙට් මාස්ක් එක කියලා. ඒතකොට ඒක තමයි මේ 30 වෙනකොට දෙන්න පුළුවන් අනිත් විදිය. So either they can give it in this way or they can give it in this way. Okay. And I know that this is a headache because then you need to convert this into binary and how to find out where is the separation, but that is how the conventional people use it. Okay. Right. So therefore there are only there are only 3 default masks: 255.0.0.0, 255.255.0.0, 255.255.255.0. That is the class A default mask, class B default mask, and class C default mask. But there can be theoretically 32 different subnet masks, just 32 different subnet masks, because that subnet mask can be 1 and 31 zeros, 2 ones and 30 zeros, 3 ones and 29 zeros, and so on and up to, then it can be 30 ones and 2 zeros, 31 ones and 1 zero. Of course, if all 31s are ones, then there's no host ID. So theoretically, right? So there are only 3 default masks. Theoretically, there are about 30. Theoretically 32, but 2 of the subnet, those are not practical. Actually, not more than 2. Actually, 4 are not practical. So somewhere around 30 subnet masks are available. Can we subnet mask විදිහට මේ number theoretically 30යි තියෙන්නේ අතර. අපි 32යි කියලා ගමු. 32යි තියෙන්නේ. මොනවාද subnet mask 32? අර 1.31යි තියෙන නම්බරේ, 1.2.30යි තියෙන නම්බරේ, 1.3.29යි තියෙන නම්බරේ වගේ ඔන්නෝම subnet mask 31ක් 32ක් theoretically නමුත් ඇත්තටම 32කට වඩා අඩුයි ගාණක් එන්නේ. ඒත් එහෙම ආවට පස්සේ අපිට ආපහු මේ ස්ලෑෂ් නොටේෂන් එකේදී නම්බරේම ගන්න පුළුවන් කොතනද මේ separation එක කියලා බලන්න. Okay. Now I will be using one of the tools available here. I have shared it in our Google Classroom. Okay. So there are different subnet calculators available. I will go for one of those. Right. So here you can see they have given IP address. Of course, you can type whatever the IP address you want. And then you can see there are subnet masks. So you don't have infinite number of subnet masks. You have only limited number of subnet masks. Okay. Limited number of subnet masks. If I change it to something like 12.45.67.100, you will see different number of subnet masks also. Okay. I think I didn't change it. So, okay. So for example, you can see I change it to class B address. Okay, class B address. Let me close it. Now we have different number of subnet masks. If I change it to class C address, I have smaller number of subnet masks. For class B, little bit bigger number of subnet masks. Okay, so this number. But if I go for class A, large number of subnet masks. Even bigger number of subnet masks. Okay. So there's a reason for that. Why different classes have different subnet masks? Can anyone tell me? Can anyone tell me why? Different classes have different number of subnet masks. So this is for the class class full subnetting. Class full means we use the concept of classes. Right. So remember I told you there are two approaches, class full, classless. So if you go for class full, listen to me very carefully. Right. So that means we consider the concept of class as a major concept. Say if it is class C, this is your separation point, or the default mask is 255.255.255.255.0. If it is a class C IP address. Okay. So therefore, this is your net ID, this is your host ID, and this is 24 and 8-bit. So therefore, you have to borrow from here in case it's class full. Okay. This is a class C address. So therefore, how many possibilities are there? 25, 26, 27, 28, 29, 30, 31. Theoretically 32, but it's not practical because then there are no host IP addresses. So therefore, you can see that there are lesser number of subnet masks here because subnet mask determines where is this point. Right. So therefore, if class C, you have roughly little bit lesser than 8 number of subnet masks. Right. Little bit lesser than 8 subnet masks. So again, let's go and see. Say it's a class C. You can see that we have smaller number of subnet masks. So that means after 24-bit, 26-bit, 27-bit, 28-bit, and so on. So you can better look at it from here. Okay, you can see it starts from 24 because it's class C. Up to 24-bit, it's net ID. So therefore, now you have to play around with 24, 25, 26, 27, 28, 29, 30. I told you 31 and 32 are practically not used. That is why those two are excluded. Right. So that is when you have class C, because in class C only last octal is available for subnetting. If it is class B, now remember it is 1616, right? Right in the middle, right in the middle. So therefore here you can see it starts from 16 now. 16 to 30 because 31 and 32 are practically not usable. Because your default, your separation is right in the middle in class B. So you have to go, you can borrow from other 16 bits. So therefore you have, so same thing can be written in subnet mask. Okay, subnet mask. So therefore you have equal number of subnet masks. For example, if you select this, the mask bit will be changed. Right? Mask bit is 21. So that is subnet mask for mask bit 21. Okay. So this is for mask bit 19. But if you go for class A, that is 8 and 24 bit. So therefore, we have much more flexibility, 24 bits to play around for the subnet. Okay, so therefore, this will be from 9 onwards now. Mask bit will be 9 onwards. That means /9, /10, /11. Okay. 8 is also available. Sorry, 8 is also available. /8, /9, or you have for /8 there's subnet mask. For /9 there's subnet mask. Okay. So what is subnet mask for /8? 255.0.0.0 because 8 ones and 24 zeros. If it is /9, what will happen? Why is it /9 is 255.128.0.0.0? So basically /9 means you have 1, 2, 3, 4, 5, 6, 7, 8, 1, then 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. And this number is 255.128. Remember, this is 128.0.0. And you can see that this subnet mask is another way of writing mask bit. So therefore, if you have 10 mask bit, you have 10 subnet masks. So if it is 10, it will be this number. Right? If I change to mask bit as 10, that means we borrow 2 bits for the thing. So that is 128 plus 64. right? 128 plus 64, that is 192. Okay. So likewise, you have limited number of subnet masks, and it depends on the class also. For class C, theoretically 8 subnet masks. Class B, theoretically 16 subnet masks. Of course, reality it's less than uh, 2 less than that. And for class A, 24, but theoretically it's less than 24, basically 22 subnet masks. So therefore, don't think that you have infinite number of subnet masks. But number of subnet masks is determined by the class when it comes to class full subnetting. Right? But it's finite. For example, class 3, maximum 8, but theoretically 6, and so on. But default mask, you have only 3 default masks, because default mask determine your default mask determine when you have 3 portions, this one. So that is for class A 8, class B 16, class C 30. So therefore, we have only 3 default masks and maximum of theoretically 32 subnet masks. 32 subnet. එතකොට මේ subnet mask එක විදිහට ඕනම IP address එකක් එන්නේ නැහැ. මේ IP address නෙමෙයි අතට. අර එකේ set එකක් ඇවිල්ලා බිංදු set වෙන නම්බර IP address වගේ නම්බර උපරිම 32ක් තමයි තියෙන්නේ. ඒක මොන subnet maskද මොන IP address එකද හරියන්නේ කියලා තීරණය කරන්නේ class full වලදී class එක මත. මොකද මේ class එකෙන් දකුණු පැත්ත ටික විතරයි අපිට බරව කරන්න පුළුවන්. Okay? So any questions? I know this is not very easy to understand. So that is why I told you, you need to experience this with these tools, right? Doing some experimentation and see why it has changed like that, why some of these are disabled. So that is why not one tool, I have given you 3 tools, because then you will be little bit, maybe if you are not very happy with the first tool, maybe you might like the second tool, or you can search and find your own favorite tool. Okay, anyway, this link is not working for some reason. Let's say the third one. Yeah, so that is also working. Okay, we can just select these things and experience what is happening and so on. Okay, right. So anyway, we'll continue this concept and we'll do more questions, right? Next class also. Don't worry, this is not the end of the story, but this is the start of the story. Okay, start of the story. So how many concepts we did look at today? What is IP address? What is network ID? What is the subnetwork ID? What is host ID? Still, we have not used much about the subnetwork ID, right? And what is a class? What is default mask for a class? What is subnet mask? So basically, subnet mask determine where is this point. Okay, where is this point? Okay. And what is broadcast ID? What is network ID? And we reserve those first and last IDs for the broadcast and network subnet ID. Okay. Right. So any questions up to this point? I know that still you might have slight doubts, but after the next class, all these doubts must be resolved. Still, you may have few doubts. Few doubts. Right. So now do this as exercise. I'll give you 2 minutes. Or I can even give you 3 or 4 minutes, because you need to start thinking, and using all the theory we learned today. Can you do this? Right. Take about 2 to 3 minutes. So this is another type of MCQs, because you get a lot of MCQs from IP addresses, because examiners can easily separate out those who have understood the concept versus those who have not understood the concepts by giving this kind of questions rather than theory questions. Take maximum 3 minutes and do it. Okay, right. So this is again a type of question they can give you. Okay, right. So let's read it. The first and the last IP address of a network are, so network means a subnetwork. Okay, network are 130.192.48.0 and 130.192.63.255. Now you can see that these numbers have not been changed, but these are different. So therefore, when it comes to binary level, we are interested in this range. Okay. So the question is, find the subnet mask of the network. Or where is the separation point? So if you know the separation point, you can find the subnet mask. Okay. So the first thing you need to do is convert, because these are not changed, convert this part into binary, convert this part into binary. Okay, of course, 255 is 8 ones. And this is the first and last IP, that is, this is the subnet ID of that network, and this is the broadcast ID. Okay, right. So once you convert it, you will get something like this. Okay, so 48 is this, 0 is this, and 63 is this, and 255 is this. I am not interested in 130 and 192. Okay. Right. So now what you need to look at is, remember, it specifically says this is the subnet ID or the network ID. Okay. First type address. And last IP, that is the broadcast ID. So that means we have the IP patterns of subnet ID and the broadcast ID. Okay, sorry, sorry, not that. So subnet ID and the broadcast ID. Okay, subnet ID and broadcast ID. So remember, the first ID must be all zeros. Last ID must be all ones. First ID must be having all zeros. After that, second region. After that, second region, all zeros. Last ID must have all ones. This can be anything. So therefore, now by analyzing the bit pattern, of course, still we don't have this part. Okay. By analyzing the bit pattern, you can see that margin must be here. So that margin can't be here, because if this is my first address can't have zeros. So therefore, if margin can't be here or here, rather the margin must be here. Because then only these are all zeros, these are all ones. It can't be here also, because so then also it is all zeros and all ones, but this is bigger range than this one. So therefore, this might be further subnet. So what we need is the bigger subnet. So therefore, this is where all of a sudden everything becomes 0, everything becomes 1. Okay. So therefore, we can deduce that this must be the separation point. So that is why all 0 part become your first address, all 1 become your last address. Okay. So therefore, in CIDR notation, for the normal notation, this network is 8, 8, and 4. 8, 8, and 4. That is /20. This is a /20 subnetwork, where this separation is after 20 bits. Okay, so that means here you need have 12 bits, 8 and 4. But what they ask is not the slash notation. What they ask is from the subnet mask notation. Right, subnet mask notation. So in subnet mask notation, /20 is you have all 20 ones and 12 zeros. So this is 8 ones is 255, 8 1 is 255. You need to convert this into binary base 10. That is 4 ones and 4 zeros. That is 1, 2, 4, 8, 16 plus 32 plus 64 plus 128. Then you will get 240. And of course, this is all 0. Right? So your subnet mask is always set of ones followed by set of zeros. So therefore, for this subnetwork, either it is /20 network or network with subnet mask 255, 255, 240. And of course, for /20 always subnet is this. ඒක ඔයා calculate කරත් කවුරු calculate කරත් ඕක ඔහම තමයි. අර ඕනාවට /20 එකේ subnet mask එක අතනින් බලන්න පුළුවන්. Let's go there. /20. So here you have the /20, okay? So /20 means බලන්න drop down එක වෙනස් වෙයි දැන්. So /20 means 255.255.240 ඉතින් ඒකද අපිට අත්තා 255.255.240. Okay? So that is another type of question you can get. Okay, that is another type of question you can get. So make sure you get the biggest margin. Otherwise, you are just thinking like, okay, all zeros and all ones, but here also all zeros and all ones. Here also all zeros. So get the biggest margin. But here you can't say it is something like this because then it is not all zeros. There's a one. Okay, of course it's all ones, but this is not all zeros. So therefore, it can't be here. It must be here. Okay, right. So that is another type of question. So those are the MCQ type of questions. But in practical sense, this is the most important question. So these are the type of question you get in your second paper. Remember, in the second paper, you get only 2 questions. And if you don't understand this kind of a question, you get almost 0 for that. So then, but අනිවාර්යෙන් subject එක fail වෙන්න තියෙන chance එක වැඩි. subject මොකද ඒ question දෙක එකක් කරගත්තේ නැහැ කියන්නේ සෑහෙන ගොඩ එන්න අමාරු ඉතින් එහාට. සමහරට ඒකේ වැරදුනොත් එතන ලකුණු එකක්වත් හම්බ වෙන්නේ නැහැ. ඊළඟ question එක ගන්න අර උත්තර උඩ. Okay. Right. So this is one of the past paper question. And these kind of questions are given in A-level ICT also. මම නිකමට A-level ICT paper එකේ question එකක් ඔයගොල්ලන්ට පෙන්නන්න. අතන මේ වගේ question තමයි A-level ICT වලත් දෙන්නේ. අන්න මේක අමාරුයි කියන්න බෑනේ A-level student ලට තේරෙනවා නම්. Can see? This is a networking question. The PQR company has a department, namely finance, marketing, human resource. At present, all the activities of the PQR company are conducted manually. The company decides to computerize all their activities by establishing an IT unit with the computer lab for the staff training. Resources will be allocated for each department and IT unit as follows. Finance, 28 computers and 1 network printer and this software server and blah, blah, blah. Okay, maybe the departments or don't have computers network. The company proposed the following: local area network for each department and IT unit in order to share the specific software and resources. LANs in each department to be interconnected via IT unit. All computers to be given efficient internet connection with the help of DNS and proxy servers. So the question is, some question again are මේ A-level ICT හරි මේ ඉස්කෝලේ යන කොල්ල කෙල්ල ලියන paper එක. Right? So then they say the network administrator has received 192.168.14.0/24 as the IP address block. මේ IP address block එකක් හම්බ වෙන්නේ for the company. The IP address for the nodes are to be allocated after making the subnets from the address block for each department unit. මේ address block එක අදාළයට බෙදලා දෙන්න ඕනේ. The following incomplete table shows the subnetting. Write down the missing IP addresses for each department using the following table format. So network ID, broadcast ID, subnet mask, usable IP address range for HR department, IT department, marketing department, and so on. ඊට පස්සේ තව question එක අහලා තියෙනවා ඊට පස්සේ network diagram එකක් අඳින්න. හරි. ඒ වගේ ඔයාගේ BIT paper එකේ තියෙනවා. and BIT paper එකක් මම ඉස්සෙල්ලා A-level ICT paper එක ආරම්භ වෙන්නේ නැත්නම් ඔයගොල්ලෝ හිතන්නේ මේ මහා අමාරු වැඩ කියලා. අමාරු වැඩ නැහැ කොහොමද ඒගොල්ලෝ පාස් වෙන්නේ? ඒ අවුරුදු ඊට වැඩි අමාරු question එකක් දීලා දෙනවා. හරි. Submitting question ඒ අවුරුදු දීලා නැහැ. මේකේ finance, HR, marketing, planning ඔය හොයලා තියෙන IP address ranges ටික. Okay. Propose a suitable VLAN and IP address plan for the company, assuming that each division has 60 terminals and will expand into 100 in the near future. Draw a diagram to support the answers. හරි මේ network subject එක තේරුම් ගත්තේ නැත්නම් ආයි විභාගයට යන්න එපා. ගෙදරටම වෙලා ඉන්න. හරි. ගෙදරටම වෙලා ඉන්න. ගියාට වැඩක් නැහැ වයින් පාස් වෙන්නේ නැහැ දැනගෙන ගියේ නැත්නම් හරි. ඒකයි මම කිව්වේ මේ දවස් ටිකේ උපරිම මහන්සියලා මේක තේරුම් ගන්න කියලා. උපරිම මහන්සියලා තේරුම් ගන්න කියලා. So you can go to the YouTube, right? Do a search. තමයි දන්න දෙයක් අමතක වෙන YouTubers ලගේ ඒවත් අහුවේ වාට. ඒව නම් බලන්න එපා. See. Subnetting. Try to understand from whoever. Subnet pass explain. Right? So many ways, but first of all, try to understand from this lecture itself. මේකෙන් තේරුම් ගත්තොත් ආයෙ වෙන වෙනම හොය යන්න ඕනේ නැහැ නේ. රටවටේ යන්න ඕන. එකක් හරියට කරගත්තේ නැත්නම් නේ. ඉතින් මේකෙන් තේරුම් ගන්න බලමු. හරි. තේරුම් ගත්තොත් ඔයාලට වැඩේ හරි. ඊට පස්සේ ඕන වෙනව බලන්න මේක කීප පදන්තර හරියද කියලා. Right. So this is an exercise. And this is the most important exercise as well. Right. And you need to do a lot of thinking when we do this kind of question. Okay. Right. An organization use 192.168.10/24 network. So that this is the IP address block they have been given. මේ IP address එකක් නෙමෙයි දීලා තියෙන්නේ. IP address block එක. /24 කියන අර bit 8ම ඔයාලට හම්බ වෙනවා. සෙල්ලම් කරලා. Following are the subnetwork requirements. So department A the sales department need 100 host machines. Or we must be able to assign 100 IP addresses to the sales department. For purchasing department, we must be able to assign 50 IP addresses. Account department, we must be able to assign 25 IP addresses. Management department, or the HR or whatever, we need to assign 5 IP addresses. So they have 5 machines. Design the subnet by giving subnet ID, broadcast ID, and the valid IP ranges for each subnetwork. Right? Each subnetwork. So now you need to assign this IP address range to these departments. These departments. In a proper way. Okay. So this is how you do it. First, look at. Let's assume this is class full example. මම ඊළඟ සවස් තමයි කතා කරන්නේ classless ගැන. මොකද අද classless කතා කරොත් එහෙම රටල ගන්නවා. හරි. දැන් ඔය assume කරන්න ඕනේ ඉස්සෙල්ලා class එක බලන්න ඕනේ. class එකට අනුව මේ පැත්තේ වම් පැත්ත තමයි අපිට සෙල්ලම් කරන්න හම්බ වෙන්නේ. So this is 192 IP address. So 192 IP addresses are class C. Right? 192 IP addresses are class C. Class C means the separation. You can have කෑලි දෙකට බෙදෙන්නේ කොහෙද? This is 24 bit, this is 8 bit. So the default mask is 255.255.255.0. So therefore we have only this part to play around. අපිට සෙල්ලම් කරන්න තියෙන්නේ මේ bit 8. Right? මේ bit 8 තමයි හම්බ වෙන්නේ class C address වල. And the good news is it is /8 network. Sorry, /24 network. So /24 means මේක 28 29 වගේ නෙමෙයි අපිට මේ bit 8ම අපිට හම්බ වෙලා තියෙනවා. ඒ කියන්නේ 24, right? So default is also 24 and 8 because this is a class C address. And because this is /24 මෙයා කියන්නේ මේ subnet mask එකනේ. මෙයා කියන්නේ මෙන්න මේ point එක. හැබැයි ඒ point එකත් මෙතනම තමයි. ඇයි ඒ 24 න් දීලා තියෙන්නේ. ඒ කියන්නේ මේ අර line දෙක සමපාත වෙලා තියෙනවා මේ question එකේ. So therefore basically my third line is also here. That is subnet to, so usually we have 3 portions. Net ID, subnet part, cost part. But in this case, right now, we have allocated the entire block. සමහර question ඕම නෑ. මේ මැදින් කොටසක් අපිට දීලා තියෙනවා. දැන් මේක එහෙම නෑ අපිට මුළු block එකම bit 8ම දීලා තියෙනවා class C එකේ තියෙන. හරි? Right. So this is how we do this kind of questions. Now, one option is, since we have 8 bits, we can create one big network. One big network having 2 to the power 8 computers. Of course, 2 to the power 8 minus 2 because 2 machines are IP addresses are reserved, okay, for subnet ID and broadcast ID. So 2 to the power 8 means 2, 4, 8, 16, 32, 64, 128, 256. 256 minus 2, 254 computers. So we can create one subnetwork with 254 computers with this block. But that is not our requirement. Our requirement is not to create one network having 254 cost. Rather, we want one subnetwork with 100, another subnetwork with 50, another subnetwork with 25, another subnetwork with 5. And definitely this sum must be less than 254. Otherwise, of course, this is not practical. 100, 150, 175, 180. Altogether 180. Of course, we have 254 IP addresses. So therefore, this should be feasible, but still there can be issues. But definitely, there's a possibility that we can do this. But if the sum is more than 254, definitely this is not doable because we need a bigger block, like not /24, maybe /22 or something. Okay, right. So now this is how you do it. First, when you have different size subnetworks for each department will be allocated one subnetwork. Okay, so the idea is rather than creating one subnetwork, we want to create 4 subnetworks. Our network is subdivided into 4 subnetworks. And these guys get IP address range, these guys get IP address range, and so on. Okay. So when you allocate IP addresses, this is how you do it. First, allocate IP addresses for the biggest department or biggest subnetwork. Then the next bigger, and so on. Otherwise, we may ended up in a situation where we have allocated too many IP addresses for smaller things, and now we run out of IP addresses. So therefore, we need to do this in a very systematic way. හරි මම ඕන question එකක් හදන්නේ මේ විදිහට තමයි. මේ වගේ තියෙන. ඒක A level ICT paper එකක් එන්න පුළුවන්. ඕගොල්ලන්ගේ pass paper එකක් එන්න පුළුවන්. හරි. Right. So therefore, the biggest subnetwork is having 100 machines. So therefore, first I will allocate IP addresses for this department. And when we allocate IP addresses, අපි හරි ලෝභ විදියට දෙන්න ඕන. එයාට අවශ්‍ය අත්‍යවශ්‍ය අවම ප්‍රමාණය තමයි දෙන්න ඕන. වැඩි දෙන්න යන්න එපා. 100ක් ඕන කෙනෙක්ට 500ක්. And there's another big limitation in allocating IP addresses, that is, we can only allocate 2 to the power blocks. So we can allocate 2 IP addresses, 4 IP addresses, 8 IP addresses. For example, if someone needs 5 IP addresses, still we need to give that department 8 IP addresses. Right. So then 16, 32. For example, if a particular department needs 20 IP address, we need to give 32 IP addresses because 16 is not enough. After 16, what we have is 32. So maybe they need 20, but we need to allocate 32. Maybe they need 34, but we need to allocate them 64 because next 2 to the power is like that. So therefore, still there's a little bit of waste of IP addresses. But it's not very big waste, and also for the future expansions, we may use it. Because today maybe we have only 38 machines, maybe after 1 year, we may need 50 IP addresses. So then we have already allocated 64. So therefore, it's a little bit advantage as well. So therefore, another point you need to remember is we can only allocate IP address block of 2 to the powers. 2 IP addresses, 4 IP addresses, 8, 16, 32, 64, and so on. So therefore, when this department needs 100 IP addresses, Right? 2, 4, 8, 16, 32, 64. 64 is not enough. We have to allocate 128 IP addresses. දැන් මේ මම මේ කියන කතන්දර ටික ඔක්කොම ඔළුවේ තියාගෙන තමයි මේ ගාන හදන්න පුළුවන්. අර A level paper එකට යන පොඩි වුණොත් ඒක ඔළුවේ තියාගෙන ඉඳලා හදලා එන්නේ. නේද? ඔයගොල්ලන් බැරි වෙන්නේ දෙයක් නැහැ. semester 4 ඉන්නේද? ඒතර ඔයගොල්ලන් මේ semester 4 එන question ම තමයි අවුරුදු 18 A level අයටත් දෙන්නේ දැන්. ඒක මතක තියාගන්න. මේක අමාරු කියලා හිතනකොට හැමතිස්සෙම මේක මතක් කරගන්න. එතකොට ඔයාලට තේරෙයි මේ මම මේක අමාරු කියලා හිතන එක වැරදි කියලා. Okay. Right. So therefore now this is how you do it. Right. So let's allocate IP address for the department A because department A needs the bigger share or the 50 IP addresses. Sorry, 100 IP addresses. So how many IP addresses we need to give to the department A? 100. But because we can only allocate 2 to the power blocks, so 64 is not enough. So therefore we have no option but to allocate 128 IP addresses. So that I hope you can understand because we can only allocate IP addresses of 2 to the power blocks. And 128 means 2 to the power 7. Right? 2 to the power 7. So 2 to the power 7 means you need 7 bit to play around. 7 bit. So then we have 0, 0, 0, 0, 0, 7 zeros to 7 ones. We have 2 to the power 7 not 128 IP addresses are available. So therefore my host bit needs 7 bits. Minimum 7 bits. Minimum. And we තුනට දැන් බෙදන්නේ හදන්නේ. So we already know that where is this? Because they have given it as a slash notation. 24. දැන් තමයි දන්නා මේක 24 කියලා දානවා. හරි? So already we know that this is 24 because they have given it. Now what we want to do is borrow some bit from this because this is the net ID and we have the 8 bit for the host, but we are going to borrow a few bit from the host side to create a subnet ID. And for the biggest department, we need 7 bit here because otherwise we can't support 100 machines. 100 machines. Okay, so 100 machine means 128. So therefore we need 7 bit for the host. So that means we can only borrow 1 bit from the host side, only 1 bit. Okay, so this is my original block. So from that we are going to borrow this bit for the subnet and keep this for the host of that particular bit department, department A. And remember, so this bit can be either 0 or 1. So this bit can be either 0 or 1. So you can allocate any of the bit. You can allocate this bit 0 bit for the department A or you can allocate bit 1 for the department A. It doesn't matter. It doesn't matter. So let's assume we allocate 0 bit for the department A. 0, then this 1 is available for future usages. අපේ ඉදිරි වැඩවලට ඔය 1 කියන bit එක තියෙන pattern එක තාම available. Because we have allocated 0. If you allocate 1 for department A, 0 is available for others. So let's allocate 0. ඔයාලට හැමදේම ලියන්න ඕනේ එක scenario එකකට කරගෙන ගියාම ඇති. ඔයා කියන්නේ 0 assign කරා කියලා. So then 1 is available for other subnetworks. So why did we assign only 1 bit? Because 1 bit is enough. Because we need only 120. Okay. Right. So then what will be the first address and last address of that network, that subnetwork we assign to department A? That is the question. So first address will be 192.168. Of course, this is also not changed. Okay, that is 1 and 0 and all zeros. And its broadcast ID will be, this is 0 that is allocated to department A and all the others are 1s. So what is that number? 192.168.10. That is the subnet ID for department A. Broadcast ID for department A is 192.168.1 and 0 and 7 ones. So that is 127. So now we know what is the IP address range for department A. 192.168.10 to 192.168.127. 128 minus 2 IP addresses are allocated for department A because these two addresses are reserved. Now we have done the first part, allocating IP addresses for department A. Okay. So අපි ලියන්නේ department A එකේ subnet ID එක 192.168.10/25 කියලා. මොකද අපි මෙතනින් බෙදුවේ /25 කියන subnet ID එක නැත්නම් අපි ID range එක වෙන්නේ මෙයාගේ ඉඳලා මෙයාට host ලගේ IP address range එක වෙන්නේ 192.168.112 to 192.168.126. හරි එතකොට සමහරට අහන්න පුළුවන් valid IP range එක මොකක්ද කියලා. සමහරට අහන්න පුළුවන් valid host ලගේ IP range එක මොකක්ද කියලා. valid host ලගේ IP range එක කියන්නේ මේ IP address දෙක අයින් කරලා මැද තියෙන IP address range එක. මොකද මේ දෙක හරි එතකොට so the question can be either what are the valid IP address range for the department or what are the valid IP range for the host. host කිව්වොත් මේ දෙක ගන්න නැහැ. මේ දෙකට ඇතුලේ තියෙන IP address range එක තමයි. So this is the valid host IP range එක මෙලියලා තියෙන්නේ. host IP range එක 101 වල ඉඳලා 126 වෙනකම්. මෙහෙම තමයි subnet ID එක දෙන්න ඕනේ. පළවෙනි IP address එක slash මේක බෙදුවේ මෙතනින් හද දැන් 8.10.24.25. Right. Now we have done for the department A. Now remember this 1 and XXX. XXX means those are any bit patterns is available for us. But this must be 1 because 0 is already used for the department A. That now we want to check how are we going to allocate IP addresses from this range now. Then මේ මුළු range එක නෑ දැන්. දැන් තියෙන්නේ මෙන්න මෙයා විතරයි. පටන් ගනිද්දි මේ මුළු range එකම තියුණා අපිට. දැන් මේ 0xxx ටික දීලා ඉවරයි. 1xxx ටික තමයි ඉතුරුලා තියෙන්නේ අපි ගාව. So that we will give to the next bigger one. Right? So the next bigger one is purchasing department or the department B, which they need only 50 IP addresses. Again, when they need 50, we have to give 2 to the power. So in 2 to the power sense, 50 means 64. Because 2, 4, 8, 16, 32, 32 is not enough. Then we have to go for 64. Right? So we need to allocate 64 block. So 64 is 2 to the power 6. That means we need 6 bits. Minimum 6 bits. අඩුම ගානේ bit 6ක් තියෙනවා සෙල්ලම් කරන්න. නැත්නම් එතකොට hostලා 64ක් හදන්න පුළුවන් නැත්නම් 50 support කරන්න පුළුවන්. So remember already this 0 is allocated for department A. So therefore we have the 1. 1 and XXX. මතක නේද අපිට ඉතුරුලා තියෙන්නේ කොහොමද? 1 XXXXXXX. So out of that now here we need minimum of 6 bits. 1, 2, 3, 4, 5, 6 bit. 6 bit නැතුව අපිට 64 block එකක් හදන්න බෑ. So now if we allocate 6 bits, so already we have only 1 only. So therefore for this one we will give 0. Or මෙයාට 1 දෙන්නත් පුළුවන්. එතකොට ඉතුරු වෙනවා 0. ගොඩක් අය මෙයාට 0 දෙන්න. එතකොට ඉතුරු අයට 1 තියාගන්න. So remember this 0 is already given, but now 1 0 is allocated to department B. So then 1 1 XXX is still available. Or we can allocate 1 1 to this department, then 1 0 XXXX is available. Okay. Right. So now I can write what is the IP address range because the first IP address will be 1 0 and all zeros. Last address will be 1 0 and all ones. And that is the subnet ID and the broadcast ID. And the valid host IP address will be 129 to 190. ABZ1. So we have allocated 64. Out of 64, only 62 is available for host. Out of those 62, any 50 can be assigned to machines. And for future, you have another about 12 IP addresses available for expansions. Now we have this. මෙන්න මේ රේන්ජ් එකද අපි ගාව ඉතුරුලා තියෙනවා. හැමතිස්සෙම ට්‍රැක් කරන්න වාර ගාව ඉතුරු මොකද්ද? 1 1 XXXXX is available to us. 1 0 දීලා ඉවරයි 0 set එක දීලාත් ඉවරයි. 0 set එක කලින්ම දුන්නා. ඊට පස්සේ 1 එකෙන් 1 0 එක දීලා දැන් 1 1 set එක ඉතුරුලා ඉන්නවා. මොකද බෙදලා දෙනවනේ හරිම ලෝභ විදියට. ඉල්ලන අයට අවම දෙදී යනවා. නැත්තම් අගායට දෙන්නේ IP address නැහැ. Right. So now we have the 1 1 and 6 bits available. 1, 1 and 6 bits available. Let's give it to the department C because department C is the next bigger department, 25. Right. So remember now we have 1, 1 and 6 bits. Right. 1, 1 and 6 bits. 1, 1 and 6 bits. Okay. 1, 1 and so this is the block we have. Now this one needs 25 machines. So 2 to the power bigger than 25 is 32. That means 2 to the power 5. That means we need minimum 5 bits. Bit පහක් මෙයාට දෙන්න ඕන හොස්ලා හදාගන්න මෙච්චරක් හදාගන්න 32ක් හදාගන්න. So that is 1 2 3 4 5. Remember what we have is 1 1 block. එහෙනම් අපි මෙයාව 0 සහ 1 කියලා ආයි කඩමු. So let's give 0 to department C, then 1 1 1 this block is what වෙනද අපිට ඉතුරු වෙන IP block එක එන්න පොඩි වෙනවා. තව ටික තවත් පොඩි වෙයි. හරි. කමන්නේ අපිට දැන් ඉතුරු වෙන ඕනෙත් පොඩි network. Right, so now you can give the first IP address and last IP address for department C. 110 all zeros, first IP address or the subnet ID. 110 all ones, the broadcast ID. So that is 192 and 223. So the valid IP address will be 193.2.222. We have allocated 30 IP addresses. Though you need only 25, we need to allocate 30. So now remember we have this block. කොහොමද අපේ අතේ ඉතුරු වෙච්ච බ්ලොක් එක තමයි 111 and okay 111 and set of මේක yy නෙමෙයි අතරම එන්න ඕනේ x දිගටම xx හරි වැරදිලා y දෙකක් වෙදලා තියෙන්නේ ඒ y එක වෙන්නේ මම එකක් ෆික්ස් කරන්න නැත්නම් කාය අමතක වෙනවා y දෙකක් එන්නේ නැහැ x දෙකක්ම තමයි. Right. So now we have this block. So what we have is 192.168.1.111 XXXX block because 110 is already assigned to C. Okay, 111 block එක තමයි දැන් තියෙන්නේ. 111 block එක තියෙන්නේ. හොඳට බලන්න මතක තියාගන්න. 111 1 2 3 ඔන්න block එක තමයි දැන් අපි ගාව අතේ තියෙන්නේ. So the next bigger department is department D, and they need 5 machines. So the next bigger 2 to the power is 8. So therefore we need minimum 3 bits. අඩුම ගානේ bit 3ක් ඕන. අපි අඩුම ගානේ දෙමු. දැන් අපි ගාව තියෙනවා දැන් bit 5ක්. So we have 5 bits to play around, but 3 bit is enough. එහෙනම් අපි 3 bits enough නම් අපි මොකටද එයාට 16ක් දෙන්න ඕනේ නැහැ නේ machine. අපි යාට machine 8ක් දෙමු. machine 8ක් දෙමු. හරි ඕනවට 16ක් දෙන්න පුළුවන් දැන් අපි ගාව දැන් ඉතුරු වෙච්ච තියෙනවා. Let's give them only 8 machines rather than 16 machines because they need only 5 machines. So therefore we will allocate only 3 bits. Right. So that is 11100 එක දෙමු. මොකද මෙතන 00 ඉන්නවා 01 ඉන්නවා 10 ඉන්නවා 11 ඉන්නවා. අපිට ඇත්තටම bit pattern 3ක් ඉතුරු වෙනවා මෙතනින්. because when we allocate 00 01 is available, 10 is available, 11 is available for other networks. එහෙම නැත්නම් මේ වගේ network හතරක් හදන්න පුළුවන් අපිට මේ අට ඒවා. So let's give the 00 blah blah blah. Then the first ID will be 111000000. Last one will be 111000111. Or in other words 224 and 231. So the usable one will be 2252 230. So they need 5, but we have allocated 6. Allocated 6. ෆෝන් නම් අපිට මේ වෙලාවේ 8කට එකක් නැතුව 16ක දෙන්නක් තියුණා. මම දුන්නේ මෙතන 8ක එකක්. මොකද එයා ඉල්ලන්නේ 5යිනේ. Right, now we have this block. ඇත්තට මේ block එකේ වාට තියෙන්නේ 01 10 11 කියන කැරක්ටර් තුන විතරයි. මොකද 00 එක දැන්ට දීලා තියෙන්නේ. 11100 එක දීලා තින්නේ. So දැන් ඔක්කොටම department වල දීලා ඉවරයිනේ. department වල දීලා ඉවරයි. එතකොට දැන් ඉතුරු block එකක් අපි ගාව මොකද උනේ? ඉතුරුණා. So this is so we allocated this one for the department, sorry, not department B, department D. Right. So we allocated 11100 for the department D. Now this block is available to us. available for එක අනාගතයේ වැඩවලට අපිට පොඩි network හදන්න පුළුවන්. ලොකු network හදන්න IP address නෑ දැන් මේ වගේ අපිට පුළුවන් තව ඕන 01 network එකක් හදන්න 01xxx එකක් 10xxx එකක් 11xxx එකක්. හරි. ඒ කියන්නේ අපිට ඕන තව 8 sub network 3ක් හදන්න IP address ඉන්න අපේ ගාව. 8 sub network. එහෙම නැත්නම් අපිට පුළුවන් 4 sub network ඊට වැඩියෙන් හදන්න. තව bit අඩු කරගන්න. නමුත් අපිට ඉස්සරහට ඕනේ ටිකක් ලොකු sub network නම් අපිට 8ට වැඩිය sub network හදන්න ඉඩ නෑ දැන්. අපි ගාව IP address නෑ. හැබැයි 8 sub network 4කට IP address තියෙනවා. blocks තියෙනවා අපි ගාව. මොනවාද? 11101 block එක 11110 block 11111 block එක තියෙනවා. අන්න එහෙම අපිට තව sub network 3ක් හදන්න අපි ගාව IP address තියෙනවා 8 ඒවා. So that is available. ඒතර මේකේ department E එකක් තියෙනවා නම් එයාට 8ක් ඕනේ කියලා අපිට දෙන්න පුළුවන්. එයාට 10 එක මෙයාට දීලා ඕනනම් sorry 00 එක මෙයාට දීලා ඕනනම් 01 එක දෙන්න තියුණා අපිට E department එකට. F department එකට 10 එක. ඕනනම් අපිට තව department 4ක් දෙන්න තව 3කට දෙන්න පුළුවන්. 8 ඒවා ඉල්ලන 8ට අඩු ඒවා ඉල්ලන. නැත්නම් 6ට අඩු ඒවා ඉල්ලන නැත්නම් මොකද 6යි effective හම් වෙන්නේ. ඒ වගේ IP address 5ක් ඕන තව department 3ක් තියෙනවා නම් ඒ 3ටත් දෙන්න අපි ගාව IP address තියෙනවා තාම. So that is how you do it. ඕක නිකන් අර අංජනක් බලනවා වගේ IP address කියන්නේ නැහැ. කොහොම calculate කරලා තමයි IP address කියන්නේ. එහෙම නැත්නම් ලකුණු හම් වෙන්නේ නැහැ. ඒතර A level ICT paper වල සමහරවිට ඒගොල්ලෝ IP address range 3 4 ලියනවා. ඇයි ඒ? මොකද එක ස්ටුඩන්ට් ලට එක විදිහට හිතෙන්න පුළුවන් නේ. කෙනෙක් හිතනවා අපි 0 එක දෙනවා කියලා. තව කෙනෙක් හිතනවා නෑ අපි 1 එක දෙනවා කියලා. ඒතකොට මාර්කින් ස්කීම් එකේ පැදුරක් වගේ තියෙනවා මේකත් හරි මේකත් හරි මේකත් හරි කියලා. පේපර් මාර්කින් කරන අයට පිස්සු හැදෙනවා මේ පේපර්ස් වල ලකුණු දෙන්න ගියා. හරි. මොකද පොසිබල් අපිට තීරණය ගන්න බෑ 0 දෙනවද 1 දෙනවද කියලා. හරි. Right. Any questions? So after creating the required subnets, there is a remaining IP range we may use for future subnetworks. Okay. Right. Right. So in the next class, we will do more questions related to subnetting. Because then theoretic කරන්න පුළුවන් දැන් theoretic කරන්න පුළුවන් දැන්. Subnet සම්බන්ධ ඔක්කොම කතා කරලා ඉවරයි. වෙන මොකුත් කතා කරන්න දෙයක් නැහැ. දැන් අපිට තියෙන්නේ මේ data packets ගැන, routing ගැන, IP protocol එකේ තියෙන data packet එකේ structure එක වගේ දේවල් කතා කරලා. But we'll be doing few more questions in the next class, right? Some past paper questions, some BIT past paper questions, as well as some A-level ICT paper questions, okay? A-level ICT second paper questions, right? So we'll stop at this point. So today I was planning to do Agile, but I just wanted to finish it entire subnetting part, almost entire subnetting part, so that I just wanted to do it in a continuous way. Otherwise, if it is discontinued, it will take more time. So maybe in the next class, we can spend more time for the agile or project management and so on. Okay. So these are the technical subjects we take more time, right? We stop at this point, right? Thank you.